parts of Examsnet. Welcome to the question series of Examsnet. Students, you must have explored our website www.examsnet.com. This site is a great place for you to practice your entrance exam question papers because all the PDF solutions of every entrance exam question paper is available there. Students, you must download our app for a better preparation of your exams. The link is available in the description box. Today, we'll be solving EAPCET 16 May 2023 Shift 1 paper. We'll be solving the mathematical part of the paper, which is consisting of 80 questions around. So let's start with the very first question. A very best of luck. Here we go. Question number 1 says, let that be a function from real to real numbers defined by this. If A is the element in the domain whose image is 1 by alpha. Yeah. So this is not A, actually, this is alpha only. Okay. Where alpha is an element in the domain whose image is 1 by alpha, then sum of all possible values of alpha is equal to. Fine, this is pretty easy actually. You are having fx is equal to 2x plus 1 upon 3. So you are given that f of alpha is equal to, this will be equal to 2 alpha plus 1 upon 3. Now you're given that this is equal to 1 by alpha, right? You're given in the question that if alpha is an element in the domain, its image is 1 by alpha. So that means f of alpha is equal to 1 by alpha. This gives me this. So you have 3 is equal to 2 alpha squared plus alpha, or 2 alpha squared plus alpha minus 3 is equal to 0, or 2 alpha squared plus 3 alpha plus 3 alpha minus 2 alpha minus 3 is equal to 0, which makes it, I'm taking this. So 2 alpha plus 3 minus 1, 2 alpha plus 3 is equal to 0. Here you will have alpha minus 1 and 2 alpha plus 3 as a two factors. So that means alpha can be equal to 1 or minus 3 by 2. Now, sum of all possible values of alpha will be minus 1 by 2. Right? So this is the answer to the question. We have option A as the answer. Hope you understood this. Let's move to the next question number 2. Fx is given by the modulus of x and gx is given by the modulus of x plus a, where a is greater than 0. For x belonging between 0 to b, there exists xy such that gx is between gx is less than equal to y is less than y is less than equal to fx. Represent all the points in the interior of a parallelogram, triangle, square, or circle. Okay, so we are having first this, and second thing this. So where a is greater than 0, that means if I'm going to make it on the coordinate axis, this will look something like this. So this has got to be, this is straight line. Okay, don't go on my drawing. It's a bit curved, but it's actually a straight line. Okay. Yeah, it should be a straight line. So this is fx and gx is x plus a. So gx will be somewhat like this. So this is your gx, right? Okay, so here you have a greater than 0. Therefore, you are given x lies between 0 and b such that this is true. Therefore, this curve represents all the points in the interior of this. Question number 2. Let fx be defined by the modulus of x and gx be defined by modulus of x plus a, where a is greater than 0. For all x between 0 and b, there exists a set xy with the ordered pair xy such that y lies between gx and fx. That is, y is greater than equal to gx but less than equal to fx. This represents all the points in the interior of a parallelogram, triangle, square, or a circle. So you're having two functions in the question. The first is this and the second is this one. Let's draw them on the coordinate axis. So here is the coordinate axis. The first one, this is the function fx, and this is the function gx. Okay. Now you are given that x lies between 0 and b. Therefore, this thing, the set of all ordered pairs x, y, such that gx is less than equal to y is less than equal to fx. This curve represents all the points in the interior of a parallelogram from here. This curve represents all the points in the interior of parallelogram. That makes option A to be the answer. Hope you got that. Let's move to the next question. Question number 3, if there is a paired order, a non-singular submatrix in matrix P of order m is to n, then what is the rank of P? Now you are given in the question that there exists a kth order non-singular submatrix in P of order m is to n. So if it is non-singular, that means the determinant of this k by k matrix is not equal to 0. Now, what do you mean by the rank of a matrix? Let's discuss that. See, maximum number of linearly independent rows or columns. Independent rows or columns of a matrix is called its rank. Right, therefore the rank of the matrix cannot exceed of a matrix cannot exceed the number of its rows or columns. Right? See, if you consider a squared matrix of like having which are having the square number of rows and columns as same. If we consider square matrix, this will be linearly independent only if the matrix is not singular. Right? Or you can say the rank of any non-singular matrix of order k is k itself. Okay, so therefore in this question, the rank is equal to k. This is the first thing. So when you have that this rank is equal to k, rank is equal to k, and also this rank is less than equal to k is less than equal to minimum value of m and n in this case, right? So these are the two possible values. Let's check with the options. Yeah, we have this thing because is equal to k is not mentioned here, but we have this thing mentioned over here. That makes option C to be the answer for the question. Hope you understood that. Next is question number 4. A is given by this matrix, B is given by this, then which of the following is true for the matrix? See, you are having the transpose A and B transpose in all the options. So let's go first of all for that. Okay. So you are having A matrix as this, and this is the B matrix. Option A, let's pick up this one. So here this is B transpose. So this can be written as A transpose I A. That's equal to B transpose. Now here you have the same thing. So this is I and B. So know one thing that A transpose into A, this is equal to this. This is equal to the identity matrix. That is what I have used over here. right? So now identity matrix multiplied by any matrix, it will give me the same. So this is A transpose into A. This is equal to B transpose into B. That ultimately will close up this, right, is equal to A, and this is equal to B. So ultimately, you know this, so that A transpose into A is not equal to B transpose into B, because the value of the elements, they are not similar in both the matrices. There are different elements. Since A and B matrix are different, has different elements, have different elements, therefore this is not true. Okay, so that means option A is incorrect. Let's move to the option B now. The orders of this and this, they are equal. So let's move to the option B now. So from here, you are given that the order of A transpose into A, which is 3 by 3 matrix, 3 by 2 matrix, is equal to order of BT into V. So this is again 3 by 2 matrix. What will be the order of this? This will be given by 2 bytes. Sorry, this will be 3 by 2. Question number 4, if A is this matrix, B is this matrix, and which of the following is true? So fine, we'll pick up all the options because they are very much different. So very first one is this, and this is equal to this. Let's pick up this. You know that B into B transpose and A into A transpose is equal to A into A transpose is equal to B into B transpose. This is equal to identity matrix. So this will now become A transpose into identity matrix into A is equal to B transpose into identity matrix into B. Also one thing, when any matrix is multiplied by the identity matrix, you get the same thing. So A transpose into A is equal to B transpose into B, because A into I matrix is equal to A, and this is equal to B matrix itself. Now you know that A matrix is different and B matrix is different. Therefore, this is not true. They are not equal because they have different elements. Correct? That means you have option A as incorrect. Let's move with the B option. Orders of this and this, they are equal. Let's write on the matrix. First of all, again the same thing. You have A transpose B, B transpose into A, B transpose, that was A transpose into B. You know, again, they are identity matrix. So you have A transpose identity matrix A, B transpose identity matrix B. And then you have, see, this thing will be equal to A only, and this thing will be equal to B only, right? Now, what is the matrix A's order? A is having the order number of rows are 2, columns are 3. A transpose will have the order of 3 by 2. So A transpose into A, this will have the order of 3 by 3, because you have A transpose into A. So it will be 3 by 3. Now let's get back here. Same thing, you have a B matrix, order is number of rows into number of columns. B transpose, number of rows and columns will get reversed. What will be the order of this? Order of B transpose into B. This is equal to 3 into 3. Right? They both are same. So that means we have option B as the correct answer. This is the correct one. Let's move to the option C. The orders of A plus B, this and this are equal. Let's write down. So you have three matrices. First is, this is option C, A plus B, and then you had the A transpose B, B, A transpose B, and the last one was BA transpose. B A transpose, right? So what was the order of A? A had the order as 2 by 3, and B had the order as 2 by 3 as well. A transpose 3 by 2, and B transpose 3 by 2 as well. So what is A plus B? It will have the same order, 2 by 3. A transpose B. A had A transpose as 3 by 2, and B had this. So this is having the order of 3 by 3. And B A transpose B had this, and A transpose had this. So this is having the order B 2 by 2. So obviously they are all different. That means this is also wrong. Rank of A and B are equal. See, rank of A and B depend on the determinant of A and B. So therefore, this is, you can't say, because the elements are different for A and B. That means this is also wrong. So we have option B as the correct answer. Hope you understood this. Let's move to the next question, number 5. So here we go in the matrix A. If all the submatrices of the kth order are singular and there is no non-singular submatrix of order R which is less than k, then the rank of the matrix A. So in matrix A, all the submatrices of the kth order are singular. In the given matrix, all submatrices of kth order they are singular, and there is no non-singular submatrix of order R. Correct? Therefore, the determinant of A of the order K by K is equal to 0 because they are singular. And for the order R by R, this is not equal to 0. Right? So that means what is mean by the definition of the rank of the matrix? We already discussed that in the previous question. It says that for any non-singular matrix of the order this K or R, the rank is determined by the same. Therefore, in the question, by the definition of rank of a matrix, here the rank of A is given by rank of A is this rank of matrix A is greater than equal to R and less than K. All right, that makes option A to be the answer. Hope you understood that. Next is question number 6. If root of minus 3 minus 4 iota is equal to R e raised to power iota theta, then what is the formula for this? Okay, so here you have root minus 3 minus 4 iota is equal to R into e raised to power iota theta. I can write it like this. This can be written as minus 4 plus 1 like this. Sorry, here is R e raised to power iota theta, or this can be written as this will be this can be written like this. This is a square, so iota minus 1 whole square is equal to this. Now, how is that? If I say 2 iota minus 1 whole square, this is equal to 1. This is like plus 2 iota square minus 4 iota, and 2 iota square, this is equal to, sorry, wait. Yes, 2 iota whole square. Okay. So this will be equal to minus 4 iota. So I can write it like this only. Correct? So this makes me this gives me 2 iota minus 1 is equal to R into e raised to power iota theta. Now let the polar form be given by R e raised to power iota theta is equal to R cos theta plus iota R sine theta. So from these two equations, first was this one. From, let's say this is equation 1. So from equation 1, we get 2 iota minus 1 is equal to this. So on comparing the real and the imaginary parts, you will get this is equal to minus 1. So r cos theta is equal to minus 1 and r sin theta is equal to 2. That gives me cos theta is equal to minus 1 by r and sin theta is equal to 2 by r. Also, r square cos square theta is equal to 1 and r square sin square theta is equal to 4. Let's say this is equation 2, 4. Both of these. Now, what you had to find out was r square tangent square theta. So, r square tangent theta, r square tangent theta or tangent square theta. So, r square tangent theta, this can be given as r square into this sine theta upon cos theta, right? So, this is equal to r square. What is sine theta equal to? This is 4 upon r square and this is 1 upon r square. So, that makes it r square into 4. This is equal to r square tangent theta, right? Question number 6, if root of minus 3 minus 4 iota is equal to this, then what is the value for r square tangent theta? Okay, let's write it. You can write it like this. I can write minus 3 as minus 4 plus 1 minus 4 iota is equal to r into e raised to power iota theta. And now this can be written as 2 iota minus 1 whole square. How is that possible? See, 2 iota minus 1 whole square is equal to a square, which is this, plus b squared minus 4ab, right? So, iota square is equal to minus 1. So, this gives me minus 4 plus 1 minus 4 iota. Correct. This is equal to r into e raised to power iota theta. So, that means 2 iota minus 1 is equal to r into e raised to power iota theta. Let's say this is equal to number 1. Also, by the polar form, you have e raised to power iota theta is equal to r cos theta plus iota r sin theta. So that makes this equation 2 iota minus 1 is equal to r square cos theta plus iota r square sin theta. Sorry, there is already, I forgot to write this r over here. So this is r only. Okay, that's why. Yeah. So this is equal to r cos theta plus iota sin theta. Now comparing the real and imaginary parts. Comparing real and imaginary parts, you have r cos theta is equal to minus 1 and r sin theta is equal to 2. That gives me cos theta is equal to minus 1 by r and sin theta is equal to 2 by r. Okay, so now you have to find out r square tan theta. According to the question, you had to find out this r square tangent of theta. Before that, I will do one thing. Cos square theta is equal to 1 upon r square and sine square theta is equal to 4 upon r square. Adding both of them, sine square plus cos square theta is equal to this. So you have this, right? This is equal to 1. That means 1 is equal to 5 upon r square, or this gives me r square is equal to 5. Now let's get back to our question. What we had to do, we had to find out r square tangent of theta. What is r square? We just solved. R square was equal to 5. So this is equal to 5. Tangent theta is sine theta upon cos theta. That was equal to 5 upon 2 by r minus 1 by r. So this gives me minus 10 as the answer. So here we have option D as the correct answer. Hope you understood this. Next is question number 7. Z1 is equal to 2 minus 3 iota, and the roots of this equation are iota, Z1, Z1 conjugate. Then what is B plus C plus D? Okay. So you are given here Z1 is okay. You're given Z1 is 2 minus 3 iota. So the given equation is Z cube plus BZ square plus CZ plus T is equal to 0. So now it is having three roots. First one was iota, then you had Z1, and then you have Z1 conjugate. Right? Let's say this is alpha, beta, and gamma. Right? Now you know one thing, sum of roots is given by minus half the coefficient of z squared divided by the coefficient of z cube. So this is going to give me minus b. That means minus b is equal to iota plus this plus its conjugate. So this gives me b is equal to, on solving this will give me b is equal to minus iota plus 4. Now similarly the sum of product of the roots, that's alpha beta, beta gamma, and alpha gamma, this is given by the coefficient of z upon the coefficient of z cube, that is equal to c. So here you have iota into 2 minus 3 iota plus 2 minus 3 iota into 2 plus 3 iota plus iota into 2 plus 3 iota is equal to c. That on solving, whole thing on solving will give you c is equal to 2 iota minus 3 iota square plus 4 minus this plus 2 iota plus 3 iota square. Now you know iota square is equal to minus 1. So this will give me C is equal to, on solving, 4 iota plus 30. Now, product of the roots. So product of the roots, that is alpha, beta, gamma, is equal to minus d upon the coefficient of z cube. So this is equal to minus d. And you have iota into 2 plus 3 iota, 2 minus 3 iota actually. 2 minus 3 iota, 2 plus 3 iota is equal to minus d. So this is 4 plus 9 is equal to minus d, or d is equal to minus 13 iota. Right. What you had to find out was b plus c plus d. So this is equal to minus 4 minus iota minus 4 plus 4 iota plus 13 minus 13 iota, or this is equal to 9 minus 10 iota. So this is the answer, 9 minus 10 iota. Option C is the correct answer. Hope you understood this. Let's move to the next question. Next is question number 8. If omega is a complex cube root of unity, then what is the value for this expression? All right, we know one thing, that a minus b omega into a minus b omega whole square, this is equal to a square plus ab plus b square. And if I take a is equal to 1, if a is equal to 1 and b is equal to 1, then this expression will be equal to 1 minus omega into 1 minus omega square. You know, this is equal to 1 minus omega into 1 minus omega square. This will give me on solving, like this will be 1 minus omega square minus omega plus omega cube. So this is equal to, this thing is equal to 1 plus 1 plus 1, that is equal to 3. Now if I take omega a is equal to 2 and b is equal to 1. So yeah, if I take this, then this will be 2 minus omega into 2 minus omega whole square, which in solving will give you this 2 square plus 2 plus 1. So by continuing the same trend, this summation becomes summation from k is equal to 1 till 7 k minus omega square pi into pi upon 175. This is equal to, this will give you 1 square plus 2 square plus 3 square till 7 square plus 1 plus 2 plus 3 till 7 plus 1 plus 1 plus 1 7 times into pi upon 175, right? So you see the trend, this can be written as 1 square. So 1 square plus 1 plus 1. Here I'm having 2 square plus 2 plus 1. So similarly, I'm following the same trend. 1 square plus 2 square plus so on. 1 plus 2 plus so on. 1 plus 1 plus so on. Right, so the squares, the formula is given by for the squares of them. This is equal to n is 7 in this case. So you have n into n plus 1 into 2n plus 1, which is equal to 15, right? Whole divided by 6 plus, this is n into n plus 1. So 7 into 7 plus 1, 8 divided by 2 plus 7 whole thing multiplied by pi upon 175. This was equal to, this is like 2, 5, 4, this. So here you have 140. Here you will have 28 plus 7 pi upon 175. So this is equal to 175 into this. So this is equal to pi itself, right? Okay, but I don't have pi over here. But you know one thing, if I take, okay, sorry, I forgot this cos thing, right? So what is cos of pi? That's -1, right? So the answer to the question, option A. Hope you understood this. Next is question number 9. That the two values of z, the complex number that is equal to this be z1 and z2. If argument of z1 is less than argument of z2 and both of these things lie between minus pi by 2 to pi, then what is the sum of argument z1 plus argument z2? First of all, let's say this is x plus iota y. So according to the question, x plus iota y is equal to this. Let's rationalize this. So here you have 1 minus iota square upon 1 plus 1 whole under the root. So you are having 1 by root 2. This is equal to 1 minus iota in the numerator. I'm writing it properly. X plus iota y is equal to plus minus 1 upon root 2, or I can write it like this. Okay, so comparing the real and the imaginary parts, you have x is equal to plus minus 1 upon root 2 and y is equal to same thing. Yeah. So you're having actually two values, right? Wait, I will rewrite this thing. You had this x plus iota y is equal to this. So here you are having the two values for this are this and this. So according to the question, z1 will be equal to 1 by root 2 plus, or I'll take the minus for this one. And let the z2 be equal to this. All right. Now we find argument z1 and z2 argument. Argument z1 is given by the tangent inverse of minus 1 by root 2 divided by 1 by root 2, or this is equal to tangent inverse of -1. So you have argument z1 is equal to minus pi by 4. Similarly, let's find out argument z2, which is given by tangent inverse 1 by this upon minus 1 by this, which is again equal to tangent inverse -1, that is equal to argument z2 is equal to 3 pi by 4. Actually, this is equal to pi minus pi by 4. So we have 3 pi by 4. So now you have to find out the value of argument z1 plus z2. This is given by minus pi by 4 plus 3 pi by 4, which will be equal to 2 pi by 4 or pi by 2. So you have option D as the answer. Hope you understood this. Let's move to the next question. beta are the roots of this equation. Then the quadratic equation whose roots are this and this is. Okay, so here you have the equation. This is x squared plus x plus 1 is equal to 0. So applying the quadratic formula, which is minus b plus minus root of b squared minus 4ac upon 2a. So here you have a minus 1 plus minus 1 minus 4 upon 2. This will give me minus 1 plus minus root 3 iota upon 2. So that means x can have the two values, minus 1 plus this, and the second one minus 1 minus this. These are the two values. Now that means x can be equal to omega square or omega. So you have the two roots as omega and omega square. So alpha raised to power 2023, this is equal to omega raised to power 2023. And beta raised to power 1012 is equal to omega square 1012. Omega raised to power 2024. And you know one thing, if I divide 2023 with 3, I'll like get the remainder of 1. Okay, so this makes me give omega into omega raised to power something cube into raised to power something, which is 6, 7, and 4. Okay, so this gives me the omega value only. That means alpha raised to power 2023 is equal to omega, and beta raised to power 1012, this is equal to 2024. Again, if I'm dividing 2024 with 3, you have 6, 18, 22, 7, and 21 and 14. So here you have 4, that's 12. So on the same way, this is omega square into omega cube raised to power 674, which gives me omega square only. So you have the two roots for the given equation, which is 2020, alpha raised to power 2023, that is omega, and beta raised to power 1012, which is equal to omega square. So the two equation with the roots omega and omega square is nothing but required equation is this only. Okay, x squared plus x plus 1 is equal to 0. That makes option A to be the correct answer. Hope you got that. Next question number 11. Alpha and beta are the roots of this equation. Then what is the value for this? Okay, so the given equation is 2x square minus 4x plus 3 is equal to 0. Let the two roots be alpha and beta, which is given. So the sum of the roots is minus of the coefficient, minus the coefficient of x divided by the coefficient of x square. This is equal to 2. Also, the product is equal to c upon a, which is equal to 3 by 2. All right. So now let's find out all the terms. First of all, let's go for finding alpha squared plus beta square. That's alpha plus beta whole square minus 2 into alpha beta. So this is 2 square minus 3 into 2, 3 by 2. So this is 4 minus 2, that is equal to, 4 minus 3. Let's write it down. That is 1. Next one, alpha raised to power beta raised to power 4. This is equal to alpha square plus beta square whole square minus 2 alpha square beta square. So this we already solved. This is equal to 1 minus 3 by 2 square. This is equal to 1 minus 9 by 2. So 1 minus 9 by 2, the answer will be minus 7 by 2. Now let's fill in this equation everything. So let's write down to find out was 2 alpha raised to power 4, beta raised to power 4. Further was plus 3 alpha square beta square whole divided by alpha plus beta. So here you have 2 into minus 7 by 2 plus 3 into 1 whole divided by alpha plus beta was equal to 2. So minus 7 plus 3 upon 2. Here you have minus 2 as the answer. So this is the answer to the question, minus 2, option B. Hope you got that. Next is question number 12. Alpha and beta are the roots for this equation, then the equation whose roots are alpha plus beta and 1 upon alpha plus 1 upon beta are. You have the equation as ax square plus bx plus c is equal to 0. So now you have alpha and beta as the roots. So what is the sum of the roots? Minus coefficient of x upon the coefficient of x square. And the product of the roots will be given by c upon a. Okay, so one thing you got, alpha plus beta you got, and next thing that you need is 1 upon alpha plus 1 upon beta. So let's go and find this. This is equal to this beta plus alpha, or this is this. So this is minus b upon a, c upon a, or this is equal to minus b upon c. Now you have to make the equation with these two as the roots. So equation with this and this as roots. This is given by, the formula for that equation. It's given by x square minus sum of roots into x plus product of the roots is equal to 0. So let's use the same thing. So here you have x square minus sum of the roots, which is alpha plus beta plus this into x plus the product of the roots. This is equal to 0, or you have x square minus, this thing was minus b upon a, and this was minus b upon c, x plus this is equal to 0, or you have x square plus bc plus ab upon ac, x plus b square upon ac is equal to 0. Let's cross multiply with ac. So this will be bc plus ab x plus b square is equal to 0. So this makes, here we have option C as the answer. Hope you understood this. Next question number 13. If the roots of this equation are in harmonic progression, then the greatest root is. So you have the equation 16x cube minus 44x square plus 36x minus 9 is equal to 0. Let's say alpha, beta, and gamma are the three roots. It's a cubic polynomial. Alpha, beta, and gamma are three roots. So sum of the roots is given by minus 44 upon 16, or this is equal to 11 by 4. Also the sum of the product of the two roots, this is c upon a, so 36 upon 16, 9 upon 4. Also the product of the roots, alpha, beta, gamma, this is d upon a, which was d 9, minus 9. So minus of minus 9 upon a was 16. So you have 9 upon 16 in this case. Let's say this is 1, 2, and 3. Now you're given that the roots are in harmonic progression. So that means alpha, beta, gamma, they are in harmonic progression. So which means 2 upon beta is equal to this 1 upon alpha plus 1 upon gamma. Let's take the LCM. You have alpha into gamma, gamma plus alpha. So you have 2 upon beta is equal to alpha plus gamma upon alpha into gamma, or 2 alpha into gamma is equal to alpha beta plus beta into gamma. Okay. Now let's put this thing in equation 2. Putting this thing in equation 2, you will have a 3 alpha gamma is equal to 9 by 4, or this is equal to 3 by 4. Let's say this is equation 1. Now let's put this in equation 4. Sorry, not equation 4. equation 3. You will get what is equation 3? This is alpha beta gamma is equal to 9 by 16. So from here, you will have alpha into gamma was 3 by 4. So 3 by 4 into beta is equal to 9 by 16, or you have beta is equal to 3 by 4. Okay. Now let's put this thing in equation 1. What is equation 1? Alpha plus beta plus gamma is equal to this. Beta is equal to 3 by 4. So you have alpha plus gamma plus 3 by 4 is equal to 11 by 4. Or you have alpha plus gamma is equal to 11 by 4 minus 3 by 4, which is equal to 8 by 4. Or this is equal to 2. Let's say this is equation 5. Now from equation 4 and 5, from equation 4 and 5, 5 is this. You have alpha plus gamma is equal to 2. And what is the 4 one? Yeah, alpha into gamma is equal to 3 by 4. Alpha into gamma is equal to 3 by 4. And this is equal to 2. Okay, wait. Greatest root is, we have to find out the greatest root. Okay. Solving these two equations, you get gamma is equal to 3 by 4 alpha. So I'll use in this equation, you have alpha plus 3 by 4 alpha is equal to 2, or 4 alpha square plus 3 is equal to 8 alpha, or 4 alpha square minus 8 alpha plus 3 is equal to 0. So let's split the middle term. So this will be 4 alpha square, 2 terms whose product is 12, and minus 8 the sum. So you 6 and 2, of course. Yeah, minus 6 alpha minus 2 alpha plus 3 is equal to 0, or 2 alpha, here is 2 alpha minus 3 minus 1, 2 alpha minus 3 is equal to 0. So 2 alpha minus 1, 2 alpha minus 3 is equal to 0, or you have alpha as 1 by 2 and 3 by 2. Now let's put this in equation 4. What is equation 4? Alpha into gamma was equal to 3 by 2. So you will have the two values for, see, alpha was equal to 1, 3 by 2 and 1 by 2. So here the gamma will be equal to, it was 3 by 4 alpha. So this will be equal to, like 3 and 3 will cancel. And wait, this will be 3 by 4 into this. So here you have 1 by 2. And the second one, when I'm putting this, is 3 by 4 into 2. So this is equal to 3 by 2. So see, you have two values. Alpha is equal to 1 by 2, 3 by 2. The corresponding of value of gamma will be 3 by 2 and 1 by 2. So from here, and also we calculated the beta. Beta came out to be, was 3 by 4, I think. Let's check. Yeah, beta was 3 by 4. You had to find out the greatest root. So greatest root among all of these is, of course, 3 by 2. No doubt. That's it. We got the answer. 3 by 2 is the greatest root. We have here option B to be the correct answer. Hope you understood this. Let's move to the next question. Question number 4. N divides 16 factorial, and 2 raised to power n does not divide 16 factorial. Then what is n? Fine. 16 factorial is given by 16 into 15, 14, 13, 12, so on till 2 into 1. So you can write it, see 16 factorial. This can be written as like 16 can be written as 2 raised to power 4. And here will be 8. So this is 2 raised to power 3. Then you have 2 raised to power 2. And then you have the 2 alone. Right. Also, let's see. Let's pick up 2 from here also. So here you have 1, 2 and wait. This will be into 15 into 2 into 7 into 13 into 2, actually 4. So 2 raised to power 2 into 3 and into 11 into 10 into 9 into 8. I have already written 8 over here, into 7 into 6 and into this 5. 4 I have already written over here, 3, 2 have been written over here into 1. So let's rewrite it. This can be written as 2 raised to power 4 plus 3 plus 2 plus 1 plus 1 plus 2 and plus 1 plus 1 into 15 into 7 into 13 into 3 into 11 into 5 into 9, 7, 3, 5, 3 into 1. Right. So this, let's see, this gives me a total of 9, 10, 11, 12, 13, 14, 15. So this is equal to 2 raised to power 15 into this whole thing, 15 into 7 into 13, 3, 11, 5, 9, 7, 3, 5, 3, 1. Okay, so that means 16 factorial can be written as 2 raised to power 15 into, let's say this whole thing is equal to k. Okay, this whole thing is equal to k. So you have k as 16 factorial upon 2 raised to power 15. Now you are given that 2 raised to power n divides 16 factorial. And 2 raised to power n plus 1 does not, you're given this thing, right? Does not divide 16 factorial. So that means 2 raised to power n will be equal to 2 raised to power 15. Of course, this k, because this does not have any factor of 2. So that means 2 raised to power n will be equal to 2 raised to power 15 for sure. N is equal to 15 then, right? So here it is. We have option B as the answer. Okay, because it will be 15, 30, 45 like that. And of course, you don't have any other number which is a divisor of 15 in the case, in the options. Let's move to the next question. Number 15, coefficient of x raised to power 4 in this expression is, let's write down the expression. So you have 1 upon cube root of 1 minus 2x raised to power 2 is this thing. So this is equal to, you can write it properly, like this can be written as 1 minus 2x raised to power 2 by 3, or I can say it this, right? Now by using binomial expansion, you can write it as 2 by 3, 2 by 3 plus 1 plus 2, so on, 2 by 3 plus r minus 1 into 2x raised to power r, whole divided by r factorial, right? So this is equal to 2 by 3 into 5 by 3, 8 by 3, 3r minus 1 upon 3 into this thing, whole divided by r factorial, or I can write it like this, 2 into 5 into 8, so on till 3 raised to power, 3r minus 1 upon r factorial into 2 raised to power r divided by 3 raised to power r into x raised to power r, right? So the coefficient of, you have to find out the coefficient of x raised to power r. So coefficient of x raised to power r is 2, 5, 8, 3r minus 1 divided by r factorial 2 by 3 r. Okay, this is the answer to the question. Let's check with the options. You have a C as the answer. Hope you understood this. Next is question number 16. If this expression 3x raised to power 5c0, sorry, 3x into 5c0, 8x into 5c1 plus whole this thing is equal to k into 2 raised to power 4, then you have to find out the value of k. Basically, you have to solve the LHS. So let's write down the LHS. So this is not x actually. This is multiply. Okay, in the whole question, this is multiply, not the x. So this can be written as 3 into 5c0 plus 8 5c1, 13 5c2, 18 5c3, 23 5c4, 28 5c5. So this thing, this is equal to 3 into 5c0, 8 into 5c1, 13 5c2, 18 5c3, 23 yeah, 18 5c3. No, sorry, it can be written as 18 5c2 itself. Why? I'll just tell you. Plus 23 5c1 plus 28 5c0. The reason is NCR is equal to NC n minus r. Okay, so now this is equal to this is 5c0 and 28 5c0, this 0, so this is equal to 31 into 5c0 plus this and this is again equal to 31 5c1, and adding both of them you'll again get 31 into 5c2. I'm taking the 31 common now, so here is 5c1, that is equal to 5c0, that is equal to 1 only, and this is equal to 5, and this is equal to 5 into 4 upon 2, that is equal to 10. So you have 31 into 16, which is equal to 31 into 2 raised to power 4. Let's compare it with the given one, k into 2 raised to power 4, so that means k is equal to 31. So here you have option C as your answer. Hope you understood this. Right, let's move to the next question, number 17. The least value of n such that this plus this is less than NC8 is. So you are given here that n minus 1 C6 plus n minus 1 C7 is less than NC8. You know one thing, that NC7 is greater than NC8, right? Because NCR plus NCR plus 1 is equal to n plus 1 C R plus 1. So this thing can be written, NC7 can be written as n factorial upon n minus 7 into n minus 8 into factorial into 7 factorial. Let me write this thing. This can be written as NC7 can be written as n factorial upon 7 factorial into n minus 7 factorial. This is less than n factorial upon 8 factorial into n minus 8 factorial. Correct? Now I'll do one thing. I'll multiply both the sides with question number 17. The least value of n such that n minus 1 C6 plus n minus 1 C7 is less than NC8 is. Okay, so let's write down. You are given n minus 1 C6 plus n minus 1 C7 is less than NC8. So, you know one thing, that NC7 is always less than NC8 because NCR plus NCR plus 1 is equal to n plus 1 CR plus 1. Right, so this can be written as n factorial upon 7 factorial into n minus 7 factorial is less than n factorial upon 8 factorial into n minus 8 factorial. Or you can write it as like n factorial upon 7 factorial, and I can write it like n minus 7 into n minus 8 factorial is less than n factorial upon 8 into 7 factorial into n minus 8 factorial. So these two things will cancel from both the sides. So what you will have that is 8 is less than n minus 7 or n is greater than 15. So the least value of n will be 16. Okay, that makes option C to be the answer for the question. Hope you understood. Next, question number 18. If a 7-digit number formed by the distinct digits this x and y, let's read it again. The 7-digit number formed by 4, 6, 9, 5, 3, x and y is divisible by 3, then the number of such ordered pairs x and y is. What is the divisibility test of 8? You know, the sum of digits should be divisible by 3. Sorry, not 8, 3. What is the divisibility test of 3? Sum of digits should be divisible by 3. Hence, let's add all of them. 4 plus 6, 9, 5, 3, x and y. This should be equal to some 3k, multiple of a 3. That means 27 plus x plus y should be divisible by 3. So x plus y, that means x plus y is also a multiple of 3, because 27 is a multiple of 3. Therefore, x plus y is also a multiple of 3. Let's say this is 1 and 2. So again, since all the 7-digit numbers has to be distinct digits, therefore x and y will be chosen from. All the 7 digits are distinct digits. Therefore, x and y will be chosen from 0, 1, 2, 3 will not be included because it has already been included, 4, 5, 6. So 7 and 8. These are the 5 digits from which x and y values will be chosen from. Okay. Now, the possible values are, if x is equal to 0, y will not be equal to possible. Why? See, 1, 2, 7, 8. None of them is a multiple of 3. So y will not be possible. If I'm choosing x is equal to 1, if I'm choosing x is equal to 1, so y can have the value as 2 and 8. Then only it will be a multiple of 3. See, what will be the pairs in this case? 1, 2, 1, 8. X if will be 2, then y can have the value of 1. So the possibility 1 and 7. So the possibilities are 2, 1 and 2, 7. If x is equal to 7 and 8, possible values of y are this and this, and from here the y are 1 and 7. So what will be the possible values? 7, 2 and 7, 8. So here will be 8, 1, 8, 7. So how many ordered pairs did you get? 1, 2, 3, 4, 5, 6, 7, 8. 8 ordered pairs. Correct. So what is the answer to the question? You have option B as the answer. Hope you understood this. Next is question number 19, sine raised to power 4 pi by 8 plus sine raised to power 4 3 pi by 8 plus this is equal to. Okay, so see, sine raised to power 4 pi by 8 can be written as this can be written as. So this can be one thing. Before starting with this, I would like to discuss one formula, that is 1 minus 2 sine square a is equal to cos 2a, right? Or you can say 1 by 2, 1 minus 2 cos a is equal to sine square a, correct? Or squaring both sides, you will have 1 minus cos 1 by 4 into 1 minus cos 2a whole square is equal to sine raised to power 4a. So let's compare this pi by 8 with a, like in all the cases, you will get, this can be written as, this is equal to 1 by 4, 1 minus cos pi, 2 into pi by 8, this is equal to pi by 4 square plus 1 by 4 cos, 1 minus cos 3 pi by 4 plus 1 by 4, 1 minus cos 5 pi by 4 whole square plus 1 by 4, 1 minus cos 7 pi by 4 whole square. So these things, now let's open it up. You will have 1 by 4. And what is cos pi by 4? This is equal to 1 by 2 whole square. Question number 19, sine raised to power 4 pi by 8 plus this plus this plus this is equal to. Before starting with the question, I would like to discuss one formula, that is, cos 2a is equal to 1 minus 2 sine square a, or 2 sine square a is equal to 1 minus cos 2a, or sine square a is equal to 1 by 2 1 minus cos 2a. Squaring both sides, you have sine raised to power 4a is equal to 1 by 4, 1 minus cos 2a whole square. So this thing will become now, this can be written, this whole expression which is given to us can be written as 1 by 4, 1 minus cos 2a. This will be pi by 4 whole square plus 1 by 4, 1 minus cos 3 pi by 4 whole square plus 1 by 4, 1 minus cos 5 pi by 4 whole square, 1 by 4, 1 minus cos 7 pi by 4 whole square. This is equal to, what is cos pi by 4? That is equal to 1 minus 1 upon root 2 whole square. And this is equal to 1 plus root 2, 1 by root 2 whole square plus 1. This will be this whole square, 1 by 4, sorry, here was plus, 1 minus this thing whole square. So that makes it 1 by 8 root 2 minus 1 whole square, 1 by 8 root 2 plus 1 whole square, 1 by 8 root 2 plus 1 whole square, 1 by 8 root 2 minus 1 whole square. I'm taking 1 by 8 common, and let's open up the squares as well. First thing, you will have 2 into root 2 minus 1 whole square plus 2 into root 2 plus 1 whole square. And I'm going to take 2 common outside. This will be 1 by 4 root 2 minus 1 square root 2 plus 1 square whole square, 1 by 4. Open up the square. So 2 plus 1 minus 2 root 2, 2 plus 1 plus 2 root 2. They will cancel. And here you will have 6 by 4 or 3 by 2 as the answer. So here you have option C as the correct answer. Hope you understood this. Next is question number 20 in a triangle ABC. If cos A into cos B into cos C is equal to 1 by 5, then what is the value of tangent A into tangent B plus tangent B tangent C plus tangent C tangent A? Okay, all right. So let's start. You have this thing, cos A into cos B into cos C as 1 by 5. Okay. I'll start with this. You have to find out tangent A into tangent B, B, C, C, A. So let's open it up. Sine A, cos A, sine B, cos B, sine B, cos B, sine C, cos C, sine C, cos C, sine A, cos A. Let's take the LCM. So you will have the whole LCM will have cos A into B into cos C, and here you will have sine A into sine B into cos C, sine B, sine C, cos A, sine C into sine A into cos B. Okay, so further this can be written as minus cos A, cos B, cos C plus cos A plus B plus C. Whole thing divided by cos A into cos B into cos C. Now, why is that? You know one formula that the cos A plus B plus C is equal to cos A into cos B into cos C minus cos A sin B sin C minus sin A cos B sin C minus sin A sin B cos C. Okay, so I have used this identity over here. Hope you got that. So further, this is equal to, I see in this case, this is compulsory that A plus B plus C should be equal to 180. Okay. Okay. So you were also given that this is equal to 1 by 5. So let's fill in this thing. So you have cos A plus B plus C, this is equal to cos of 180. So this is equal to minus 1. So let's get back to here. This is equal to minus 1 by 5 plus of minus 1 divided by minus 1 by 5. This is equal to minus 6 by 5 upon minus 1 by 5, or this is equal to 6. So here you have option C as the answer. Hope you understood this. Next is question number 21. If cos theta minus alpha, cos theta plus alpha, they are in harmonic progression, then what is the value for this tangent? 2 tangent square alpha, theta. Okay, fine. So these three are in harmonic progression. That means 2 upon cos theta is equal to 1 upon cos theta minus alpha, 1 upon theta plus alpha, or 2 upon cos theta is equal to whole thing. This is multiplied, this is equal to theta minus alpha, theta plus alpha. Here you will have cos theta plus alpha. I'm opening it, okay? Theta plus alpha, this is equal to cos theta, cos alpha minus sin theta, sin alpha plus, I'm opening this as well. This is equal to cos theta, cos alpha. Here was a minus and here will be plus. Yeah. Sin theta, sin alpha. Okay. Yeah. So these two things will cancel out. And you will have 2 upon cos theta is equal to 2 cos theta cos alpha whole thing divided by cos theta minus alpha cos theta plus alpha. Okay. Yeah, that they are equal. So let's do the cross multiplication now. You have 2 cos theta minus alpha into cos theta plus alpha whole thing divided by cos theta is equal to 2 cos theta cos alpha. Right? Yes, let's open it up again. So you will have this is cos A minus B into cos A plus B. So first thing, the 2 and 2 will get cancelled. And this is cos theta cos alpha minus sin theta sin alpha cos theta cos alpha plus sin theta sin alpha whole thing divided by cos theta is equal to cos theta into cos alpha. So this is a minus b into a plus b types thing. So you have cos square theta, cos square alpha minus sine square theta, sine square alpha uh, divided by cos theta. I'm taking cos alpha over here. This is equal to cos theta, right? Now cos square theta, cos square alpha minus, I'm changing this one minus sign as a sine square alpha, like sine square theta can be written as 1 minus cos square theta into sine square alpha divided by cos theta, cos alpha is equal to cos theta itself. So I'm taking cos square theta common now. Here you have cos square alpha plus sine square alpha minus, here was sine square alpha, whole thing divided by cos theta, cos alpha is equal to this. This is equal to 1. So you have cos square theta minus sine square alpha is equal to cos square theta into cos alpha itself, right? Hope you're clear till here. So sine square alpha is equal to cos square alpha. I'm theta, taking common cos square theta, this will be 1 minus cos alpha, or cos square theta is equal to sine square alpha upon 1 minus cos alpha. Hope this is clear till here. Now, what you had to find out in the question was 2 tangent square theta. Let's go to that. So you had to find out was 2 tangent square theta, which is equal to 2 sine square theta upon 2 cos square theta. What is sine square theta? This is 1 minus cos square theta. I'll find sine square theta over here. Sine square theta is equal to 1 minus this upon 1 minus this. So this is equal to 1 minus cos alpha minus sine square alpha whole thing divided by 1 minus cos alpha. So this can be written as 2 into 1 minus cos alpha minus sine square alpha divided by 1 minus cos alpha divided by this. So this can be written as this. Okay. So this and this will eventually cancel out. Okay. Then you will have this as this is equal to 2 into 2 sine square 1 minus cos alpha can be written as 2 sine square alpha by 2 minus sine square alpha whole divided by sine square alpha. So that is equal to 4 into sine square alpha by 2 minus this sine square alpha minus 1, right? Sorry, 2. So splitting it again, I'm keeping the numerator as such 4 sine square alpha by 2 and let's open up the denominator, that is sine square alpha. This is equal to 2 sine alpha by 2 cos alpha by 2 whole square minus 2. Yes, so this thing will cancel. This is 4 sine square alpha by 2 upon 4 sine square alpha by 2 cos square alpha by 2 minus 2. These things will cancel, or you have secant square alpha by 2 minus 2. Hope you're clear till here, right? So secant square alpha by 2 minus 2 can be written as secant square alpha by 2 minus 1 minus 1. And you know secant square alpha by 2 minus 1 is nothing but tangent square alpha by 2. So this is equal to tangent square alpha by 2 minus 1. Now let's check with the options which one is the correct. We have option A as the answer. Hope you got this. Next question number 22. So if cos A plus B plus cos A plus 2B, so on up to n terms is equal to this, then this is equal to what? This whole expression is equal to what? So let's start with the given one. You have to find out cos pi by 19, 3 pi by 19, 5 pi by 19, 7 pi by 19. Okay. So you are given this thing. Do remember, I will transfer this in terms of this now. Let's see how we are going to do that. So cos pi by 19, I'll let it be like this. So here I'm having this as my A. Cos pi by 19 plus cos A plus B. So 3 pi by 19. Keeping the A, this can be written like this. So here this is your B and this is your A. Plus cos A plus 2B, right? Or better to write like this, 2B, correct? So this goes on till plus cos A plus, how many terms? See, you're having 17 over here. So how many times you're skipping by 2? This has got to be 8 terms. Sorry, it will be 9 terms. How? See, this is a forming an AP with the first term as 1 plus 3 plus 5 plus so on till 17. So I'm applying Tn is equal to A plus n minus 1 into D. So 7 is equal to 1 times n minus 1 into 2. 16 is equal to n minus 1 into 2. Here you will get n is equal to 9. Okay. So here you are having like this is the first term, second term, and this is n minus 1. So here you will have 8 into 2 pi by 19. Okay, right. Now you are given in the question that this is equal to this. So cos 2a or 2 pi by 19. I'm going to write it like this. 2 pi by 19 plus 9 minus 1 into 2 pi by 19 whole thing divided by 2 into sine 9 into 2 pi by 19 into 2 cosec 2 pi by 19 into 2. Hope you're clear. Like I have just opened up this and I have equated this to this as well. Hope you understood. Now this is equal to cosecant 2 pi upon 19 plus 16 pi upon 19 whole thing divided by 2 sine 9 pi by 19 cosec pi by 19. This is equal to 2 cos 9 pi upon 19 into sine 9 pi upon 19 whole thing divided by 2 sine pi by 19. Okay, so this is 2 cos A, cos B. That means this is equal to sine 2A. And you have sine 18 pi upon 19 upon 2 sine pi upon 19, right? 18 pi upon 19 can be written as pi upon 19 itself. So you have 1 by 2 as the answer. Here you have 1 by 2. Option C is the correct answer. Hope you understood. Next is question number 23. If two angles alpha and beta are such that alpha is greater than 0 and beta is less than pi by 4 and the root of 1 plus cos 2 alpha is equal to 3 by root 5 and this thing is equal to 1 by 7, then what is the value for 2 alpha plus beta? Okay, so fine, let's start with here. Well, you're given 1 plus 1 plus cos 2 alpha is equal to this thing and this thing is there, right? So from here, I'm doing squaring the both sides. 1 plus cos 2 alpha is equal to 9 by 5 or cos 2 alpha is equal to 9 by 5 minus 1, which is equal to 4 by 5. So cos 2 alpha is this, this can be written as 2 cos square alpha minus 1. Cos 2 alpha is 2 cos square alpha minus 1. This is equal to this, or 2 cos square alpha is equal to 4 by 5 plus 1, which is equal to 9 by 4. Or cos square alpha will be equal to 9 by 10, or cos alpha will be equal to this, right? So I got the cos alpha. What will be the sin alpha in this case? So sin alpha is equal to 1 minus sin square alpha is equal to 1 minus cos square alpha, 1 minus 9 upon 10, which is equal to 1 by 10. This is sin square alpha, or you have sin alpha as 1 by root 10. What will be tangent alpha in? You have sin upon cos. So this thing upon this thing, you have a tangent alpha is equal to 1 by 3. Okay, what we had to find out was 2 alpha plus beta. Okay, so you have tangent alpha as 1 by 3. What will be tangent 2 alpha? This will be 2 tangent alpha upon 1 minus tangent square alpha is equal to 1 2 into 1 by 3, whole thing divided by 1 minus 1 upon 9. This will be 2 by 3 divided by 8 upon 9. On solving, this will be equal to 3 upon 4. Correct. Now let's get back to, we were also given one thing, 1 minus cos 2 beta upon 1 plus cos 2 beta whole under the root. This is equal to this 1 upon 7. One thing, that 1 minus cos 2a is equal to 2 sine square beta upon this is equal to 2 cos square beta. 2 and 2 will cancel. This is this. So you have tangent square beta under the root is equal to 1 by 2, or tangent beta is equal to 1 by 7. So tangent beta is equal to 1 by 7. Now you had to find out tangent 2 alpha plus beta. This is equal to tangent 2 alpha plus tangent beta whole thing 1 minus tangent 2 alpha into tangent beta. Let's fill in the values. You have all the values. This is 3 by 4 plus 1 by 7 divided by 1 minus 1 by 7 into 3 by 4. So this is, let's take the LCM. You have 28 and 21 plus 4, 1 minus 3 by 28. This is equal to 25 upon 28 divided by 25 upon 28. So you have tangent 2 alpha plus beta is equal to 1. So what is tangent 2 alpha plus beta? This is tangent inverse 1, or this is equal to 5 by 4. So the answer to the question is equal to option D is the correct answer. Hope you understood this. Let's move to the next question, number 24. Cos h alpha plus sin h alpha is equal to e raised to power 3, and sin hx is equal to this. Then what is the value for tan hx? You are given cos h alpha sin h alpha is equal to e raised to power 3. This is equal to e raised to power alpha plus e raised to power minus alpha upon 2, and this is equal to e raised to power alpha minus e raised to power minus alpha upon 2. Now you're given that this is e raised to power 3. Let's take the LCM. So you have e raised to power alpha, e raised to power minus alpha, e raised to power alpha minus e raised to power minus alpha is equal to 2 e raised to power 3. These two things will cancel. 2e alpha is equal to 2e3, or you will have alpha is equal to 3. Okay. Now, also you are given that sin hx is equal to alpha upon alpha plus 1. So this is equal to 3 by 4, right? Now, what is the sin hx is equal to? This is e raised to power x minus e raised to power minus x upon 2 is equal to 3 by 4, or e raised to power x minus e raised to power x is equal to 3 by 2. You had to find out was the tan hx. To find was tangent of tan of tan hx. This is given by e raised to power x minus this upon e raised to power x plus this. So you have this value. This is equal to 3 by 2. And for plus of this, this thing I'll solve first of all, because e raised to power x plus e raised to power minus x whole square minus 4 is equal to 9 by 4, right? So this gives me e raised to power x plus e raised to power minus x square is equal to 9 by 4 plus 4, which is 25 by 4. Or you have e raised to power x plus this thing is equal to 5 by 2. Okay, let's fill in this over here. So here you have 5 by 2 or 10 hx is equal to 3 by 5. Now let's check with the options because you are not given any directly like 3 by 5 in any of the options. Let's check the first one. Alpha upon alpha plus 2. Alpha was equal to 3. So you have this 3 upon 3 plus 2, that is 5. This is equal to 3 upon 3 minus 3, which is 0, which is actually not possible. So here you have 3 upon 7. Here you have 6 upon 2, or this is equal to 3. That makes option A to be the correct answer. Hope you understood this. Next is question number 25 in a triangle ABC. If R1 is equal to R2, 2R2 is equal to 3R3, then which of the following is true? So you are given R1 is equal to 2R2 is equal to 3R3, or you have delta upon S minus A is 2 delta upon S minus B is 3 delta upon S minus C is equal to, let's say, some K. So you will have S minus A is equal to 1 by K, S minus B is equal to 2 by K, or this is equal to 3 by K. Adding all the values, adding them, you will have this will be equal to S 3S minus A plus B plus C is equal to 1 by K plus 2 by K plus 3 by K, which is equal to 6 by K. And you know A plus B plus C is equal to 2S. So this is equal to S is equal to 6 by K. So you have 6 by K minus A is equal to 1 by K. 6 by K minus B is equal to 2 by K. 6 by K minus C is equal to 3 by K. From here, you have A is equal to 5 by K. From here, you have B is equal to, B will be equal to 4 by K. And C will be equal to 3 by K. You have to find out A is to B is to C, which will be 5 is to 4 is to 3. So 2B is equal to A plus C. That makes option C to be the correct answer. Hope you understood. Next is question number 26 in a triangle ABC. If tangent A by 2 plus tangent C by 2 is equal to B by S, then what is the value of sine A plus C upon 3? Okay, so let's start. First of all, you are given tangent A by 2 plus tangent C by 2 is equal to B upon S. Tangent A by 2, C by 2 is equal to B upon S. I can write it as sine A by 2 upon cos A by 2 plus sine C by 2 cos C by 2 is equal to B upon S. Let's take the LCM. So you will have a cos A by 2 cos C by 2 is equal to sine A cos C by 2 cos sine A by 2 cos C by 2 plus cos A by 2 sine C by 2. This is equal to B upon S, or see, this is the formula for sine A plus C upon 2. This is equal to cross multiplication cos A by 2 cos C by 2 into B upon S sine a plus b upon 2 is equal to root of s into s minus b a upon bc, root of s into this s minus c upon ab into b upon s. So this is equal to sine a plus b upon 2. I'm concatenating all the roots over here. This is equal to s into s minus a s minus c whole divided by bc into ab into, I'm taking it inside only, right? B square upon s square. So these will cancel ultimately. And you will have sine a plus c upon 2 is equal to root of s minus a s minus c upon a into c whole thing under the root. And this is the formula for sine, that's a plus c upon 2. This is equal to sine b by 2. Okay, so sine a plus c upon 2 is equal to, this can be written as a cos of pi by 2 minus b by 2, or this is equal to cos a plus c upon 2. See, you know, a plus b plus c is equal to pi, or a plus c is equal to pi minus b. Okay, so this is pi minus b upon 2. This is sine this, or you have tangent a plus c upon 2 is equal to 1. That means a plus c upon 2 is equal to, this is tangent pi by 4. This is equal to pi by 4, or in degrees term, this is equal to 45 degree, or a plus c is equal to 90 degree. Now you had to find out was sine a plus c upon 3. Sine a plus c upon 3, this is equal to sine 90 upon 3 sine 30 degree. This is 1 by 2. So this is the answer to the question. Option D is the correct answer. Hope you understood this. Next is question number 27. In a triangle ABC, triangle B is 60, angle A 75. Point D divides BC in the ratio 2 is to 3. Then sine BAD is to sine CAT is. Let's make the triangle to understand it first. So here is the given triangle. This is, let's say, A 75, 60, B, obviously the C will be 45. Okay, D divides BC in the ratio 2 is to 3. So this is D, it's dividing the ratio 2 is to 3. Here is AD. Okay. Sine BAD is to sine CAD. This is what you need to find out. First of all, sine angle BAD. And you have to find out this ratio with sine angle CAD. Let's say BD is equal to 2x and DC is equal to 3x. So by the sine rule, you have a sine BAD upon 2x is equal to sine B upon 1. And sine angle CAD upon 3x is equal to sine C upon 1. Right? So let's divide both of them. You have a 3 sine angle BAD divided by 2 sine angle CAD. This is equal to root 3 by 2 divided by 1 by root 2. Why? Because sine of B is equal to sine 60, which is root 3 by 2. And sine C is equal to sine 45 is equal to 1 by root 2. All right, so that gives you 3 sine BAD divided by 2 sine angle C AD is equal to 3 root 3 into root 2 upon root 2, or this will be equal to root 3 by 2. Okay, or this is equal to sine B A D upon sine of angle C AD is equal to, this was this, multiplied by 2 upon 3. So this will be root 2 upon root 3. So therefore, the ratio sine angle BAD sine angle CAD is root 2 is to root 3. So here you have option A is the answer. Hope you understood. Next is question number 28. If this whole expression is equal to fx plus a upon x plus b plus b upon x plus q, then what is the value for 2a plus b? Fine. So here in the question, let's divide these two things first. When you will be dividing, you have here x squared minus x minus 2. This thing is being divided with the x raised to power 4 minus 6x cube plus 9x squared 5x minus 20. So let's divide it. First, you will have x squared. So this is x raised to power 4 minus x cube minus 2x squared minus plus they will cancel, and here will be left minus 5x cube plus 11x squared plus 5x minus 20. Next you have minus 5x, so minus 5x cube 5x squared plus 10x plus minus they will cancel, and 6x squared minus 5x minus 20. So plus 6 now, 6x squared minus 6x minus 12 minus plus they will cancel, and here will be left with the x minus 8. So this term, this expression now can be written as x squared plus minus 5x plus 6 plus x minus 8 upon x squared minus x minus 2. Now let's factorize. This is x squared minus 5x plus 6 plus x minus 8 divided by x minus 1 into x minus 2. So I have to solve this thing now. X minus 8, let's say this is 1, x minus 8 upon this. One thing is, this is our fx now. So now this can be written as a upon x minus 1 plus b upon x minus 2, or this is a into x minus 2 b into x minus 1 whole thing divided by x minus 1 into x minus 2, or you have ax minus 2a bx minus b upon x minus 1 x minus 2. This was equal to x minus 8 upon x minus 1 x minus 2, or x minus 8 is equal to a plus b x minus 2a plus b. So from here you have a plus b is equal to 1 and 2a plus b is equal to 8. Minus they will cancel. Minus a is equal to this, or a is equal to 7. You had a plus b was equal to 1. So that makes b as minus 6. Okay. So that means this expression, the whole expression 1 now can be written as, this expression can be written as, from equation 1, you have x squared minus 5x minus 6 plus 7 upon x minus 1 minus plus minus this x minus 2. So now this is your fx, this is your a, this is your b. Let's compare it with the given one. You have fx upon, it was a upon x plus b, plus x up plus p, b x plus q. So this is your fx, 7 is your A, B is minus 6. You have to find out 2A plus B, which is equal to 2, 7 minus 6, that is equal to 2. Now the given options contain this F7, F6, F5, F4. Let's find all of them. So first thing, your Fx was equal to x square minus 5x plus 6. You have to find out F7, 6, 5, 4. So F7, 6, 5, and 4. This makes it 7 square minus 35 plus 6. 49 minus 35 plus 6. Surely this is not equal to 2. And 6 square 36 minus 30 plus 6. This is again not equal to 2. And here you have 25 minus 25 plus 6, which is not equal to 2. Here you have 16 minus 20 plus 6. This is equal to 2. So that means this is our answer. F of 4 is the correct answer to the question. Option D. Hope you understood this. Let's move to the next question, number 29. So if a point D, C divides a line segment joining the points with the position vector this and this in the ratio 2:3, then the distance of C from the point with the position vector this is. Okay, so you're given, let's write it down. There's a point C which divides the line segment. Let's say this is A and B. So 2I minus 3j plus 2k, which can get the coordinates as 2 minus 3, 2. And we will have the coordinates 3 minus 1 minus 2. There's a point C which is dividing this line segment in the ratio 2:3. Let's say the coordinates of C, x, y, z. So you have x as, this is mx1 plus nx2 upon m plus n. So this will give me 6 plus 6 upon 5, because 3 into 2, 2 into 3, this is 12 upon 5. And also y will be my2, my1 upon, ny1, m plus n. So this is equal to minus 2 minus 9 upon this, or minus 11 upon 5. Here you have z is equal to mz2 nz1 upon this. So this is equal to 2 by 5, right? Now the position of point C, you have the coordinates. C has the coordinates as this, right? And now you have to find out the distance between C and let's write down the C coordinates as well. Distance between C, which is this, having coordinates this, and point, you can find it out very easily. This will be 12 by 5 minus 2 square minus 11 by 5 plus 1, 2 by 5 minus 1 square, which will be this, this, and this. So 4 upon 25 is 36, 9 upon 25, or this is 7 upon 5. Okay, so you got the answer as option A. Hope you understood. Next is question number 30. If A vector is given by this, B is this, they are collinear vectors, then what is the value of this expression? See, they are the collinear vectors. You are given this. So that means 2x plus y upon 2, because they are collinear vectors. So this is equal to 3 upon 1 is equal to 9 upon x minus y, minus x minus y. Okay, so you have two things. 2x plus y is equal to 6, and minus x plus y is equal to 3. right? Let's say these two equations. Now let's solve them simultaneously. You will have a, let's like multiply this with -1 and adding over here, you have x minus y is equal to -3, or 3x is equal to 3, or x is equal to 1. Now for x is equal to 1, you have x is equal to 1, y will be equal to 4. Okay, so you got to do value, you got the value for x and y. What you had to find out was this: x cube plus 27y cube, x cube 27y cube. So 1 cube 27, 4 cube, or 1 plus this, which gives me 1729. So here we have option D is the answer to the question. Hope you understood this. Next is question number 31. So let A be this vector, B be this, C be this, D be this. They are the four vectors. If A cross B dot C is equal to 3 is equal to A cross B dot D, then you have to find out the value of 3P plus Q. Okay. So let's write down the four vectors first. The A is I minus 2j, B 2j, 3k, C, P, I, Q, J, and D is Pj minus Qk. Okay. So what do you have as the A cross B vector? This is I, J, K. So 1, -1, 0, -2, 0, 0, 2, 3. This gives me -6i minus 3j plus 2k. Okay. Also, let's go for this A cross B dot C. This is equal to 3. You're given this. So that means -6i minus 3j plus 2k pi qj is equal to 3, right? Okay, so this gives me -6p minus 3q plus 0 is equal to 3. Why? Because you know I is equal to j dot j is equal to k dot k is equal to 1. Okay. So second thing, you have also, you are also given that this thing is equal to 3 again. A cross B dot T. Also A cross B dot T. So this gives me -6i minus 3j plus 2k dot pj minus qk is equal to 3. This gives me 0 minus 3p minus 2q is equal to 0. Right. So let's solve these two equations to get the value of p and q. Okay. Let's multiply it with 2. So you have -6p minus 4q is equal to 6. And let's subtract this equation. So you have okay, let's write it first. So plus, plus, minus, they will cancel. And minus q is equal to 3, or q is equal to -3. Right. For that, let's find out the value of p now. So we have -3p minus 2q is equal to 0. -3p minus 2 into -3 is equal to 3. -3p is equal to 3 minus 6, or p will be equal to 1. Okay, got the value of p and q. P came out to be 1, q came out to be -3. What you had to find out was 3p plus q. To find 3p plus q, so you have 3 into 1 minus 3, which is equal to 0. So here you have option A as the answer. Hope you understood that. Let's move to the next question. Question number 32. Let A be this vector, B be this vector, and A1 be the area of the quadrilateral having A and B as diagonals. A2 be the area of the parallelogram with these as adjacent sides. Then what is the dot product of A1 and A2? Fine. So these are the two vectors. Note them clearly. First of all, you're having A1 as the area of quadrilateral with A and B as the diagonals, right? So you know this area is given by the half the cross product of A and B. Let's find out A cross B first. This is given by I, J, K. This first vector is 1, 2, 3. Second one is 1, minus 2, minus 3. So this is equal to minus 6 plus 6I minus minus 3 plus 3. Wait, this is minus 3, minus 3. J and plus here you have minus 2, minus 2, K. So this makes it, this will be 0 plus 6J minus 4K or 6J minus 4K. Right, so what is this magnitude? It's given by root of 6 square plus minus 4 square, which is 36 plus 16, which is equal to root of 52. Right, now the area, that means A1 is equal to half this, which is half of root of 52. Right, let it be like this only. Let's just number 1. Now you are given that A2 is the area of parallelogram having A and B as two adjacent sides. Right, so this is given by, this area is given by the modulus of the cross product of the two vectors, and we just solved. That means this is equal to root of 52. Now what do you have to find out? The product of A1 and A2. So this is equal to half of this multiplied by this. This is equal to 52 by this. 2. So 26 square units. This is the answer to the question. That means you have option A as the answer. Hope you understood this. Next is question number 33. Before starting with the question, students, there's a quick reminder to visit our website www.examsnet.com. Here you can practice this one and similar many more entrance exam question papers with their detailed PDF solutions. You must download our app for a better preparation of your exams. Let's start with question number 33 now. For some real number lambda, if area of the triangle having A, B as these two vectors as the two sides is this. I'm repeating the question. For some real number lambda, if the area of the triangle having A and B as the two sides is this, then the number of distinct possible values of lambda is. So you are given the two sides. First one you are given as 3I minus j plus lambda k, and the B vector lambda I plus j minus 3k. So this area is given to you as this. Now area of the triangle, you know, that's half the cross product of the two vectors. So this is this. 2 and 2 will cancel. So that means this is equal to root of 195. Let's find out. So this is I, j, and k. This is 3 minus 1 lambda, lambda 1, and minus 3. This is the modulus is equal to, okay, we'll talk about this later. First of all, let's solve this. So you will have 3 minus lambda I minus 9 minus lambda square j plus 3 plus lambda k. This gives me 3 minus lambda I plus 9 plus lambda square j 3 plus lambda k. So that means modulus of this is equal to root of 3 minus lambda square 9 plus lambda square plus 3 plus lambda square. Now you know from this equation, from 1, this is equal to root of 195 from equation 1. Okay, so this gives me, I'm opening the squares now. This will give me 9 plus lambda square minus 6 lambda plus 81 plus lambda power 4 plus 18 lambda square plus 9 plus lambda square plus 6 lambda is equal to 195. Now this and this will cancel. You will have a lambda power of 4 plus 1, 2, this and wait, sorry, no, 1, 18, 19, and this, not this. So you have 20 lambda plus 99. This is equal to 195. And further, this will be lambda power 4 plus 20 lambda. I'm taking this on right hand side. So this will be, this will give me 195 minus this. This is gonna give me 96. This is equal to 0. Okay, so let's find out the two factors. First of all, here was lambda square. Okay, I want two such numbers. The product is minus 96 and the sum is plus 20. So the factors will be 24 lambda square minus 4 lambda square minus 96 is equal to 0. Lambda square plus 24 minus 4 lambda square plus 24 is equal to 0. So here you have lambda square minus 4 lambda square plus 24 is equal to 0. For sure, this is true because lambda square cannot be equal to minus 24. Okay, square root of a number can never be negative. So that means you are having two values for lambda, that is plus and minus 2. So here you have option C as the correct answer. Question number 34, if the sum of square of the deviations from the mean of this data is given by this, where x bar represents mean of xi's, then the sum of squares of xi's is. Fine, you're given one thing, the sum of squares of deviations from the mean of the data is given by, in the question it is given sum of squares of deviations from the mean of the data is given by xi is equal to nx bar square. Now, what is the mean? You know, this is given by the sum of the terms divided by the number of the terms. So this is equal to n into n plus 1 divided by 2n, or this is equal to n plus 1 upon 2. So n plus 1 by 2 minus 1 square plus n plus 1 by 2 minus 2 square, so on till n plus 1 by 2 minus n square. This is n into x bar square according to the question. So this makes it, let's say you have n plus 1 minus 2 upon 2 square plus n plus 1 minus 4 upon 2 square plus n plus 1 upon 2 minus, there will be 3 to the 6, so minus 6 square, so on till n plus 1 minus 2n upon 2 square. This is given by nx bar square. This is equal to n minus 1. I'm taking 1 by 4 common for everything. I'm taking this outside, n minus 1 square plus n minus 3 square plus n minus 5 square, so on till n minus, this will be 1 minus n, which can be written as n minus 1 square as well. Okay, hope you're clear with this thing. So now I'm again taking this thing I'm concatenating the n minus 1 square, n minus 1 square. So this will be 2 into n minus 1 square, 2 into n minus 3 square. So on, ultimately you will be left with 3 square plus 1 square. This is equal to nx bar square. I'm again taking the 2 common. So, sorry, 2 here and 2 here as well. So again, I'm taking 2 common. So this is 2 by 4, n minus 1 square plus n minus 3 square, so on till this is equal to this. So this is given by, I can rearrange it, and this will be 1 square plus 3 square, so on, n minus 3 square, n minus 1 square. This was like I have taken the 2 on this side, 2nx bar square. Therefore, sum of squares of xi's is given by 2nx bar squared. So let's check with the options. Here you have option B as D as the answer. Hope you understood this. Let's move to the next question. Question number, committee of 25 members, each member is proficient either in mathematics or statistics or in both. If 19 of them are proficient in mathematics, 16 of them are proficient in statistics, then the probability that a person selected at random from the committee is proficient in both is. So you have total members 25. So members who are proficient in mathematics, proficient in mathematics 19, statistics proficient 16, and both proficient are it is okay, we don't know that, of course. That will be equal to 19 plus 20 16 minus 25, which is equal to 10. Question number 35, in a committee of 25 members, each member is proficient either in maths or stats or in both. If 19 of them are proficient in maths, 16 are in stats, then the probability that a person selected at random from the committee is proficient in both. Okay, so you have total members as 25. Total members as 25. So who are proficient in maths 19, and in stats they are 16. So how many are proficient in both? That's 19 plus 16 minus 25, which is equal to 10. So now the required probability, that is a probability that a person selected is proficient in both. So the required probability is 16 upon, sorry, not 16, that is 10 upon 25. So that is equal to 2 by 5. That's it. That was an easy one. You have 2 by 5, option C as the correct answer. Next is question number 36. If one ticket is selected at random from 30 tickets, each with a distinct number from 1 to 30, then the probability that the number on the selected ticket is a multiple of 3 or 5 is. Okay, so you have 30 tickets and each have the distinct number from 1 to 30. Now the numbers which are a multiple of 3, they are 3, 6, 9, 12, 15, 18, this and this. And the numbers which are multiple of 5 are 5, 10, 15, 20, 25, and 30. So the total number which are a multiple of 4, 3 or 5, multiple of 3 or 5. How many are those? That is 3, 5, 6, 9, 10, 12, 15, 18, 20, 21, 24, 25, 27, and then you have 30. So this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So there are 14 numbers which are a multiple of both. So the probability that the number is selected is multiple of 3 or 5. So do you have the required probability as 14 upon 30. That means this is 7 upon 15. So this is the answer to the question, 14 upon 30 or 7 upon 15. You have option D as your answer. Hope you understood. Next is question number 37. So A and B are independent events of a random experiment if and only if which of the following is true. They are given that A and B are independent events of the random experiments. So that means probability A upon B. This is given by probability A upon B C complement. That means probability A intersection B upon probability B is equal to probability A intersection B complement divided by probability of B complement. So this is probability A intersection B divided by probability B is equal to probability A minus probability A intersection B whole thing divided by, sorry, whole thing divided by 1 minus probability of B, or you have probability A intersection B minus probability A intersection B into this is equal to, doing the cross multiplication, probability A into probability B minus probability B multiplied probability A intersection B. Or you have probability A intersection B, because these two will cancel out, is equal to the product of probability of A into probability of B. That makes, sorry, no, not the option B, D as the answer. Next is question number 38. From out of 100 enrolled students, two sections of strength 40 and 60 are formed. If you and your friend are among those 100 students, and the probability that both of you are placed in the same section is. So since, see, how many total students, total enrolled students, 100. So two sections, there are two sections of 40 and 60 students each. So probability that both of you are placed in the same section, both of you are placed in same section is given by, see, from 40 you are having like two come in the same place, so this is 40 C2 plus there are 60 students in the other section, so 62 C2 divided by the total number of students from which you have to select two, so this is given by this, right? That makes option B to be the answer. Hope you got that. Next is 39th question. For a binomial distribution with the mean 6 and variance 2, find the probability that x is greater than 2 is, okay, so let's say that n and p are the parameters of the binomial distribution of binomial distribution. So mean, which is given by np, this is equal to 6, and variance npq is equal to 2. This is 1 and 2. Then let's divide them. NPQ upon NP is equal to 2 upon 6. That gives me Q is equal to 1 upon 3. So P will be equal to 2 by 3. Right. So now from equation 1, you had NP is equal to 6. So N into 2 by 3 is equal to 6, which will give you N is equal to 9. Now, first two terms of the distribution are, first two terms of distribution are probability that x is equal to 0 and x is equal to 1. This is given by NC0 1 by 3 raised to power 9, which is equal to this. And this is 9C1 1 by 3 8 upon into 2 by 3, which will give you 2 upon 3 power 7. Now you have to find out probability x is greater than equal to 2. This is given by 1 minus probability x is equal to 0 plus probability x is equal to 1, right? So this is equal to 1 minus 3 power 9 minus 2 upon 1 minus 1 upon 3 power 9 minus 2 upon 3 power 7, which will be equal to 1 minus, I'm taking here 3 power 9. So this is 3 power, sorry, here will be 1 minus, this will be 9, 9 2 is 18. So here you have this is, I will take it as plus and this will remain as minus. So this will be 1 minus 19 upon 3 power 9. This is the answer to the question. And you have option C as the answer. Hope you understood. Next, for the question, in a city, it is found that 10 accidents took place in a span of 50 days. Assuming that the number of accidents follow the Poisson distribution, the probability that there will be 3 or more accidents in a day in that city is. Here give the Poisson parameter. Lambda. Over here, this is equal to 10 upon 50. That is equal to 0.2. So now the probability that there will be 3 or more accidents in a day in that city. So probability x is greater than equal to 3, of course, like we did in the previous question. 1 minus probability that no accident takes place plus the probability 1 accident take place plus the probability 2 accident takes place. Okay, so this is given by 1 minus e power minus 0.2 into 0.2 raised to power 0 whole thing divided by 0 factorial minus e raised to power minus 0.2 this upon 1 factorial minus e raised to power 0.2 into 0.2 raised to power 2 upon 2 factorial. Right? So this will be equal to 1 minus, I'm taking e raised to power 0.2 minus 0.2 common. So this will be 1 plus 0.2 plus 0.04 upon 2, or this is equal to this. So that is 1 plus 0.2 plus 0.02. So this is equal to 1 minus 1.22 e raised to power this. So this is the answer to the question, and you have option B as the correct answer. Hope you understood this. Let's move to the next question. Next is number 41. If A is 2 by 3, B is minus 4, 5. They are the two fixed points and the locus of a point P such that the area of triangle PAB is 12 square units. Is. Okay. So you're having the triangle PAB. Let's say the point P has the coordinates x, y. So now we are given the points A as 2 by 3, B is minus 4 by 5, and P I have assumed to be x and y. Now the area of the triangle, PAB, you are given this is equal to 12 square units. So this is equal to half into, so when you're given the 3 coordinates, what will be the area? This is x into 3 minus 5, 2 into 5 minus y, minus 4 into y minus 3. This is equal to the modulus of it. This is equal to 12 according to the question, right? So let's open it up. You have 3x minus 5. Sorry, I will directly write it. This is minus 2x plus 10 minus 2y minus 4y plus 12 is equal to 24. Or here you have this as minus 2x minus 6y plus 24 is equal to this. Or you have x. This will be like I'm dividing both sides by 2. So this will be minus x minus 3y plus 11 is equal to 12. Or like I'm removing the mod, this can be written as x plus 3y minus 11 is equal to plus minus 12, right? So that means it can have the two values, x plus 3y minus 11 is equal to 12, or x plus 3y minus 11 is equal to minus 12. This gives you x plus 3y minus 23 is equal to 0, or you have x plus 3y plus 1 is equal to 0. Hence, the locus of P point is given by x plus 3y minus 23 into, this plus lambda x plus 3y plus 1 is equal to 0. This is something else. It will be multiplied x plus 3y minus 23 into x plus 3y plus 1. This is equal to 0. So let's open up. You have x squared plus 3xy plus x plus 3xy plus 9y squared plus 3y minus 23x minus 69 y minus 23 is equal to 0, or you have x squared plus 9y squared plus this and 6xy, and if I'm concatenating, this will be minus 22x, this and this. So this has almost also been written. So I'm left with this will be minus 66 y minus 23 is equal to 0. So this is the answer to the question. Here you have option C as the correct answer. Hope you understood. Next is question number 42. The sides of the triangle this and this. If P0B lies either inside, either on the triangle or inside, then P lies in the interval. Now the equation of the given lines are 3x plus 2y minus 6 is equal to 0. Here, dividing both sides by 6, you have x by 2 plus y by 3 is equal to 1. And the second is 2x minus 3y plus 6 is equal to 0. Or you have x upon minus 3 plus y upon 2 is equal to 1. And the third one was x plus 2y plus 2 is equal to 0. X upon minus 2 plus y upon minus 1 is equal to 1. So these are the three equations I have written this form. Let's try and make the triangle now. So this is your coordinate axis. Okay. Here's your coordinate axis. Now this is the first one is like 2 and 3. So here will be the points 1, 2, 3. Let's mark them first. Minus 1, minus 2, minus 3, minus 4, 1, 2, 3, 4, minus 1, minus 2, minus 3, minus 4. Okay, they are not up to the mark, but still they are like this. Okay, so this is the first point, 2, comma 0, and here is the point 0, comma 3. Right, let's make it. Let's join this one. Okay, this is, again, I'm saying not up to the scale. And the second one was the minus 3 and 2. So here you have this point minus 3 and this is the one, right? So this is the second line, right? Now the third one, minus 2, minus 1. So here you have minus 2 and this is minus 1. So this is the third line. Okay. Okay, so they will meet somewhere over here. Okay, they will meet at this point. Like now, let's get back to the question. If POB lies either on the triangle or inside the triangle, then B lies in the interval. See, this lies either on the triangle or inside the triangle. So P0B. From here, 0B, this definitely, either it is lying in the triangle or on the triangle or inside the triangle, it is lying on y-axis. So B will belong to, from this figure, B will belong to minus 1, this till 2. Right. So that makes minus 1 till 2, option C. This is the correct answer. Hope you understood this. Next is question number 43. A point on the straight line this, which is equidistant from the coordinate axis, will lie on Okay, so the equation of the straight line is 3x plus 5y is equal to 15, which can be written as x upon 5, y upon 3 is equal to 1. Again, drawing it on the coordinate axis, you will have a yeah. So this one I'm drawing here is 1, 2, 3, 4, and 5. So this is the point 5, 0, and this is 1, 2, 3. This is the point 0, 3, right? So let's join these 2 points like this. Okay, now a point on the straight line which is equidistant from the coordinate axis will lie on. Okay, the point on this straight line which is equidistant from the coordinate axis, let's say that is P, XY. So that means you want to have the X and Y like same. Okay, you want to, you can say it like X and Y in the question because they are equidistant since point has to be equidistant from the coordinate axis. Therefore, x will be equal to y. Okay. Now, what this point will be? This is 3x plus 5y is equal to 15. So 3x plus 5x is equal to 15, or 8x is equal to 15, or x is equal to 15 by 8. Similarly, you will have y also equal to 15 by 8 because x is equal to y. So the point is 15 by 8, 15 by 8. Now this lies in the first quadrant, right? There is also one more point, which is minus 15 by 2, 15 by 2. This is lying in the second quadrant. How? Because in the second quadrant, x will be equal to minus x. Therefore, 3x plus 5y is equal to minus 15. This will be minus 3x plus 5x is equal to 15, or you will have 2x is equal to 15, or x is equal to 15 by 2. Right now, since it is lying in the second quadrant, so it will be equal to, like, x will be taken as negative and y will be taken as positive because it is lying in the second quadrant. So this point will be minus 15 by 2 to 15 by 2. That makes option A to be the correct answer. Hope you got that. Next is 44th question. Equation of the line which is passing through these 2 points is, so fine, you are given the 2 points. That's pretty easy to form the equation now. You know the general formula, y minus y1 is equal to m into x minus x1. For that, let's first of all find out m. M is given by y2 minus y1 upon x2 minus x1. So this is equal to c upon t2 minus c upon t1 divided by c t2 minus c t1. All right. So here you have, I'm taking c common, t1 minus t2. Again, I'm taking c common, t2 minus t1. Right. Yeah. Also, this will be multiplied by t1 into t2. Okay. So the c and c will cancel, and you will have t1 minus t2 upon t1, t2 into t2 minus t1, or this can be written as minus t2 into minus t1, t1, t2, t2 minus t1. So these will cancel. You have 1 minus 1 upon t1 into t2. Now equation of line, you have that formula, y minus y1 is equal to m into x minus x1. So you have y minus c upon t1 is equal to minus 1 upon t1 into t2 x minus c t1, right? Here I'm taking the point c t1 and c upon t1. Okay. Now, let's do the cross multiplication. T1 into t2y minus c t2 is equal to x plus c t1, or you have x plus t1 t2 y is equal to c into t1 plus t2. So that's it. You got the equation. Now let's check with the options. Here you have option A is the correct answer. Let's check it once again. Yes. Hope you understood. Next question number 45. If the line x plus y minus k meets the curve this at 2 points A and B, if O is the origin and AOB is 90°, then the value of k, which is greater than 1, is fine. So you have the equation x square plus y square minus 2x minus 4y plus 2 is equal to 0, number 1. And the equation of the line is this, x plus y minus k uh, mm, is equal to 0, right? This should be there. So this makes x plus y is equal to k, or x plus y upon k is equal to 1. Let's say this is equation 2. This was your line and this one was your curve. Now, homogenizing both of them. Homogenizing equation 2. You will have x square plus y square minus 2x x plus y upon k minus 4y x plus y upon k plus 2 x plus y upon k whole square is equal to 0. This will give me x square plus y square minus 2x square upon k minus 2xy upon k minus 4xy upon k minus 4y square upon k 2x square upon k square 2y square upon k square plus 4xy upon k square is equal to 0. Now you're given angle AOB is equal to 90°. That means the coefficient of x square plus coefficient of y square is equal to 0. That means 1 plus 1 minus 2 upon k, 4 upon k, plus this is equal to 0, or you have 2 minus 6 upon k plus 4 upon k square is equal to 0, or 2k square minus 6k plus 4 is equal to 0. The two factors will be, first of all, this. So the two factors will be k minus 1, k minus 2 is equal to 0. So that means k can have 1 or 2 as the values. But now in the question, they have told that k is greater than 1. So that means k is equal to 2 is the only possibility, right? So that is there. Option D. This is the answer. Hope you understood. Next is question number 46. If the angle between the pair of lines this k is equal to 0 is 45, then the area in square units of the triangle formed by the pair of bisector of angles between these lines and this line is fine. Let's write it down. So you are given the lines as this 2 root 2xy plus ky square is equal to 0, and x plus 2y plus 1 is equal to 0. Let's say this is number 1 and number 2. Now the angle between the line 1, this is the pair of lines, right? So angle between the lines in equation 1 is 45 degrees. It's given over here. That means cos 45 degree is 1 modulus of 1 plus k divided by the root of 1 minus k plus 8. So what is cos of 45? This is 1 by root 2. Okay, let's write it down. So root 2 1 plus k is equal to, or I'll do what? I will just square both the sides, right? So you will have 1 plus k square upon 1 minus k plus 8 is equal to 1 by 2. Or you have 2 1 plus k square plus 2k is equal to 9 minus k. Okay, so you have 2k square plus 4k plus k. This is plus 5k. 8, 9 minus k is over here. And yes, 5k. This will be minus 7 is equal to 0. Now, two such numbers, product should be minus 14 and sum should be plus 5. That's of course 7 and 2. So 2k square, 2k. Question number 46 is the angle between the pair of lines this, where k is greater than 0 is 45. Then the area in square units of the triangle formed by the pair of bisector of the angles between these lines and this line is. Fine. So you're given this line, this pair of lines. Here k is greater than 0 and angle between those lines is 45 degree. Let's write down. You have x squared plus 2 root 2 xy plus ky square is equal to 0. So here, if I compare it to the general equation, ax square plus 2hxy plus by square is equal to 0. Here a is equal to 1, h is equal to root 2 and b is equal to k. All right. So the angle between them, 45 degree. So this makes, if I say cos 45 degree, this is given by the modulus of a plus b divided by root of a minus b square plus this is 4h square. Okay. Now cos 45 degree is 1 by root 2. Let's fill. You have a, that is 1 plus k upon root of 1 minus k whole square plus 4 into 2. So let's do squaring on both the sides. You have 1 by 2 is equal to 1 plus k whole square divided by 1 minus k whole square plus 8. Let's do the cross multiplication. So here you will have 1 plus k square minus 2k plus 8 is equal to 2. Yeah, 2 into 1 plus k square plus 2k. So this gives me 1 plus k square minus, or simply this can be written as 9 plus k square minus 2k is equal to 2 plus 2k square plus 4k. Or you have k square, this will be minus 6k plus 6k. Minus 7 is equal to 0. So let's split the middle term. You have k square plus 7k minus k minus 7 is equal to 0. So the two factors will be k plus 7 and k minus 1. And of course, the two possible values of k are minus 7 and 1. You see, you are given in the question k is greater than equal to 0. So that means k is equal to 1 and k is equal to minus 7 is not possible. All right. Next thing. The equation of the seat is given, then the area formed by the pair of bisectors of the angle between these lines. So, first of all, equation of angular bisectors of equation 1 is given by h into x square minus y square minus a minus b is equal to 0. So, h is equal to root 2 x square minus y square minus 1 minus k into xy is equal to 0. You know k is equal to 1. So this term will be 0. Or you will have root 2 x square minus y square minus 0 is equal to 0. Or simply x square minus y square is equal to 0. Now you have to find out this is the pair of bisectors. Let's say this is equation 3 and the given equation of the line was, this is given line x plus 2y plus 1 is equal to 0. Let's say this is equation 3. Now, area of triangle formed by equation 2 and 3. This will be, this is given by n square root of h square minus ab whole thing divided by am square minus 2hlm plus bl square. This will be, see, what is n in this case? This is coefficient of x, coefficient of y, and the constant. Okay, so n is equal to 1. This is 1 square root of h square, which is equal to 2. Sorry, here in this case, a is equal to 1, h is not there, so h is 0, and b is equal to minus 1. So this is equal to 0 minus a into b. So this is equal to 1 into minus 1. This is this. Okay, so now a is here, L is equal to 1, M is equal to 2, N is equal to 1. So here you have 1 into 2 square, which is 4, minus, here the h is 0, so 0, plus b is minus 1 into L square, so this is equal to minus 1. Let's solve it. You have here 1 into 1 divided by 4 minus 1. So this is equal to 1 by 3. Area is 1 by 3 square units. You have option A as the correct answer. Hope you understood this. Let's move to the next question, 47. The coordinates of the point 3 minus 7, 5 in the new system. When the origin is shifted to this point, when the translation, by the translation of translation coordinate of x's is fine. So here you the coordinates of the new origin of new origin are x is equal to minus 1, and z is also equal to minus 1. And original coordinates are given to be as x is equal to 3, y is equal to minus 7, and z is equal to 5, right? So let the, okay, let this be the capital ones. Wait. X is equal to 3, y minus 7, and z is equal to 5. Now, see, x has been transformed into x minus x, and y minus y, and z minus z. So let's substitute the values. Substituting the values, we get. So here you get x is equal to 3 minus of minus 1, y is minus 7 minus of minus 1, and z is equal to 5 minus of minus 1. So this gives me x is equal to 4 minus 6 and 6. Therefore, yeah, we got the points. And the coordinates of the point this in new system are 4 minus 6 and 6. So this is the answer. Option A. This is the correct answer to the question. Hope you understood this. Next is question number 48. Let A, B, C, they are the 3 points, L1, M1, N1. They are the direction cosines of AB. L2, M2, N2 are the direction cosines of AC. Then what is the value for L1 into L2, M1 into M2, and N1 into M2 modulus? Okay, so these are the 3 points. They are the direction cosines L1, M1, M1 of AB, and these are the direction cosines of AC. Okay, so first of all, let's write down the points. A is 1, minus 1, 2, B 6, 11, and 2, and C 1, 2, and 6. So they are having AB direction cosines L1, N1, M1, and N1, right? So what will be AB? AB will be equal to 5 minus 1, sorry, 6 minus 1, 5, 5 I cap, 11 minus of minus 1, this will be plus 12J, and 2 minus 2, this will be 0K. So AB will be given by 5I plus 12J. right? And similarly, AC will be given by. AC is having the direction cosines as L1, L2, M2, and N2. And the AC will be given by 1 minus 1. This is 0, I cap. 2 plus 1, 3, J cap. 6 minus 2, you have 4, K cap. Yeah, so this is the AC. Let's write it. 3J plus 4K. Right. So here the direction cosines are L2, M2, and N2. Okay. Now you have to find out this. Let's go. So L1, L2 plus M1, M2, N1, N2 whole modulus. This is equal to, this is given by AB dot AC upon the magnitude of it, both of them. Okay. So let's do what is AB and AC. Here we go. This is AB and this is AC. So let's do the dot product of both of them. First of all, this is 0 plus into 5, that's 0. Then 3 into 12, that's 36. Plus the K is missing again, 0. So this is divided by the root of 5 square plus 12 square multiplied by 3 square plus 4 square. So this is equal to 36 upon root of this is 25 plus 144. This is 169. And here you have root of 25. So 36 upon 13 into 5. Or no, this will not cancel. Wait. So this is equal to 36 upon 65. This is the answer to the question. And we have option B as the correct answer. Hope you understood. Next is question number 49. If the plane this meets the coordinate x's in A, B, and C, then the centroid of the triangle ABC is. Fine. So let's write down the equation of the plane. 56x, 4y, 9z is equal to 2016. So this meets the coordinate x's in A, B, and C. Now dividing the equation of the plane on both sides by 2016, you will get x upon 36, y upon 504 plus z upon 224 is equal to 1. Now, plane meets coordinate axis in A, which is given by 3600, B, which is given by 0504, 0, and C, which is given by 00224. Right, so I got the 3 points A, B, C. It's very easy to go for the centroid now. Centroid of triangle ABC is given by 36 plus 0 upon 3. 500, similarly 504 plus 0 upon 3. 224 plus 0 upon 3. So this makes it whole as 12, 168. And I will keep it as such. So let's see, it matches with option C. Hope you understood this. Next is for 50th question. If the circles this and this have 4 common tangents, then which of the following is true? Okay, so you're having the 2 equation of the circles as this plus c is equal to 0. And the second one, x squared plus y squared plus 2x minus 4y plus c is equal to 0. Here the center C1, this is given by minus half the coefficient of x, which is 1, minus half the coefficient of y, which is minus 2. And the radius, this is given by, I hope you remember the formula, g squared plus f squared minus c. So this is equal to, r is equal to root of 1 plus 4 minus c, or this is equal to root of 5 minus c. Similarly, here the C2 center is given by minus 1 and 2. The second radius is given by minus 1 square plus this minus c. So have the same radius in both the cases. So C1, C2, if I have to find out the distance between these 2 points, C1, C2 is given by 1 plus 1, that is 2 square, minus 2 minus 2, that is equal to 4 square. Right, so this gives me root of 20, which is this. Also, let's add the 2 radius. So this will be twice root of 5 minus c, right? So you see one thing, that r1 plus r2 is less than c1, c2. I'm subtracting something from 5 over here, and this is 2 root 5, and this is 2 into root of 5 minus c. Okay, this is also the condition for 4 tangents, 4 common tangents. All right, so what is this? This is less than 2 root 5. Let's do squaring the both sides. So you will have 4 into 5 minus c is equal to 4 into 5, or 20 minus 4c. Sorry, this is less than this. Yeah, so this is less than 20, or you have minus 4c is less than 0, which gives you c is greater than 0. So that's it. C is greater than 0. We have option D as the correct answer. Hope you understood this. Next, question number 51. The locus of the pole of the tangents to this circle with respect to this circle is. Fine. Let's say this is the pole, x1, px1, y1, be the pole. The polar of p with respect to x square plus y square is equal to 4 is given by x into x1, y into y1 minus 4 is equal to 0. Also, the given circle is given circle is this can be written as, this equation can be written as, I'm writing like this, x minus 1 square, y plus 1 square minus 4 is equal to 0. You will solve and you will get the same equation. Okay, here the center is given by 1 minus 1, and the radius is given by root of 4, which is equal to 2. Okay, now let's say this is equation 2, and this is equation 1. Now, if equation 1 touches the circle equation 2, if equation 1 touches the circle in equation 2, then radius is it given by distance formula I'm using. This is equal to 2, which is equal to 1 into x1 plus minus 1 y1 minus 4 whole thing divided by x1 square y1 square under the mod. So, okay, let's 2 into x1 square y1 square is equal to x1 minus y1 minus 4. Let's do on squaring both the sides. So you have 4 x1 square y1 square. This is equal to x1 minus y1 minus 4. Yeah. Yeah, this is square over here. This I forgot, and also a square over here. Sorry, this is under root will cancel. Right. So now the locus P is given by 4x square plus y square. This is x square plus y square plus 16 minus 2xy plus 8y minus 8x. This on solving whole will give you 3x square, 3y square plus 2xy, 8x minus 8y minus 16 is equal to 0. So this is the answer. Let's check with the options. You have option A as the answer. Hope you understood this. Next is question number 52. Let the circle S with the which is concentric with this circle passes through this point 3 comma minus 2. If one of the diameters of S lies along this line, then the radius of the circle S is. Okay. First thing, equation of family of concentric circle to the given circle is x square plus y square minus 2x. This is equal to 0 is plus ky plus lambda is equal to 0, which is similar to x square plus y square 2gx 2fy plus c is equal to 0. Now, because you are given that this point lies on the given circle, you are given that minus 3 comma 2, sorry, it was 3 comma minus 2 lies on the circle. Therefore, you have x square plus y square minus 2x plus ky plus lambda is equal to 0. Let's fill in the value for x and y. So you have 9 plus 4 minus 2 into 3 plus k into minus 2 lambda is equal to 0, or you have 7 minus 2k plus lambda is equal to 0. Let's say this is equation 1. Now, one of the diameters of S lies along the line 1, given that one of the diameters of S lies along the line 3x minus 2y plus 4 is equal to 0. So, what is the center? What is the center? It was, let's look at the center from here. The center is given by minus half the coefficient of x. That's 1 minus half the coefficient of y, which is minus k by 2. Therefore, center, which is 1 minus this, satisfies this equation, right? Because it is lying on this, the diameter is lying, so that means center is also lying on this line. So this makes it 3 into 1 minus 2 minus k upon 2 plus 4 is equal to 0, or 3 plus 2k plus 4 is equal to 0, or k is equal to minus 7. Sorry, k is equal to minus 7. Okay, so now from equation 1, now from equation 1, what we get is 7 minus 2 into minus 7 plus lambda is equal to 0, which will give you lambda is equal to minus of 21. Okay, therefore, this equation will be x square plus y square minus 2x minus 7y minus 21 is equal to 0. So what will be the g? This is minus 1. F is minus 7 by 2 and C is minus 21. So the radius will be given by root of G square F square minus C. So this is equal to 1 plus 49 upon 4 plus 21. That is equal to 4 plus 49 plus 84 upon 4, right? So this is equal to 88 plus 49, that will be equal to 137 under the root upon 2. So this is the answer to the question, and you have option D as the answer. Hope you understood this. Let's move to the next question. Question number 53, the length of the chord this to this circle is 2 root 3, then one of the values of k is. So let's make the circle. This is the given circle, and the equation of the circle is x square plus y square minus 6x minus 8y plus 9 is equal to 0. and this is the center, and let this be the chord. The chord equation is given by 2x plus 3y plus k is equal to 0. So from here, what is the equation of the circle? Let's write here x squared plus y squared minus 6x minus 8y plus 9 is equal to 0. Center is given by minus g minus f, or this is minus half the coefficient of x minus half the coefficient of y. 3 comma 4, the radius is given by root of g square plus f square minus c. So this is equal to 3 square plus 4 square minus 9, which will give me 4. So I got the center as 3 comma 4 and radius r as 4. So let's see, this is the center 3 comma 4 c, and this is the radius, which is 4 in this case, right? Now next, the distance between this distance, a perpendicular drop from the center to the chord. So distance between chord and center of the circle. What is center of the circle? This is 3 comma 4, and chord of the circle is given, this is 2x plus 3y plus k is equal to 0. So this distance t is given by mod of 2 into 3 plus 3 into 4 plus k whole thing divided by root of 2 square plus 3 square, which is equal to mod of 18 plus k divided by root of 13. This is equal to distance d, right? So this is d. Now let's say this is a. What will be the length of the chord? Length of the chord is twice a, and what is a equal to? By applying the Pythagoras theorem, this is r square minus d square. So this is equal to, what is r? This is 4 square minus d square. I'm just writing d like as such only. You're given in the question, length of the chord is 2 root 3. 2 and 2 will cancel, squaring both sides. You have 3 is equal to 16 minus d square, or you have d square is equal to 13, or d is equal to root of 13. Correct. Yeah. So let's fill this value of d in equation 1. So using equation 1, would you had d was equal to mod of 18 plus k upon root 13. This is equal to root 13. So this gives me 18 plus k is equal to 13 into 13, which is 13 itself. Right. Yeah. So here you get the value of yes. See, one thing, this will be plus minus 13 because I'm removing the mod now. So 18 plus k can be equal to 13, or 18 plus k can be equal to minus 13. In the first case, this is equal to minus 5, and here k is equal to minus 31. So the two possible values of k are this minus 31 and 5. Minus 5. Minus 31 is not in the options, but we have a 5 minus 5 in the options. So that makes option C to be the correct answer. Hope you understood. Next is question number 54. If Q is inverse point of P to 3 with respect to this circle, then the circle with PQ as the diameter is given by which of the equations? All right. So this is the equation of the circle, x squared plus y squared minus 2x minus 2y plus 1 is equal to 0. Let's say this is equation 1. Center is given by 1 comma 1, and the radius r will be given by root of 1 square minus 1, which is 1 only. Okay. Now you're given the point P as 2 comma 3. Polar of P with respect to first equation is given by polar of P with respect to equation 1 is x into x1, y into y1 minus x plus x1, y plus y1 plus 1 is equal to 0. This makes, I'm feeling like 2 and 3 in this equation. So this makes 2x 3y minus x plus 2y plus 3 plus 1 is equal to 0, or you have 2x plus 3y minus x minus 2 minus 5 minus 3 plus 1 is equal to 0, or x plus 2y minus 4 is equal to 0. Let's say this is equation 2. Okay, the center was C. Now the equation of CP. C had the coordinates as 1, 1, and P was given to you as 2, 3. So equation will be framed as y minus 1 is equal to 3 minus 1 upon 2 minus 1 into x minus 1. So this is equal to 2 into x minus 1, or you will have 2x minus y minus 1 is equal to 0. Let's say this is equation 3. Now solving 2 and 3. Solving second and third equation. You will get, let's write down the equations. The second one was x plus 2y minus 4 is equal to 0. And there this one is this. So let's multiply this with 2. You'll have 2x plus 4y minus 8 is equal to 0, and this one I'm writing 2x minus y minus 1 is equal to 0, minus plus plus. So you have 5y minus 7 is equal to 0, or y is equal to 7 by 5. So in this case, 2x minus y minus 1 is equal to 0. 2x minus 7 by 5 minus 1 is equal to 0, or you have 2x is equal to 12 upon 5, or you will have x is equal to 6 by 5. Right. Now let's write down x comma y is 6 by 5 and 7 by 5. Right. Now, what will be PQ? PQ will be given by, this is the point Q. So PQ will be given by, P was 2, 3. So this is 2 minus 6 by 5 square, 3 minus 7 by 5 square, which is 16 by 25 plus 64 by 25. That will give you this. So this is 4 root 5 upon 5. Now, that means this is the diameter, right? You want to have PQ as the diameter. It's given here. So the radius will be half of the diameter. Radius is half of PQ, which is equal to 2 root 5 upon 5. Okay, now from the options, we check that the radius is okay. So first one is x square plus 3y square. This equation. So from here, let's calculate the radius. This is, I have to write it down. Wait, 3x square plus 3y square. 3x square, 3y square, and minus 14x minus 16y plus 37 minus 14x. So it was 16y plus 37 is equal to 0. And let's write the second equation as well. Okay. X squared plus y squared minus 4x minus 6y plus 13. Solutions. Here, dividing both sides by 3, you will have x squared plus y squared minus 14 by 3x minus 16 by 3y plus 37 by 3 is equal to 0. So the radius is given by half the coefficient of x. This is 7 by 3 square plus 8 by 3 square minus 37 by 3. You will solve it out, but you will check that this is not equal to 2 root 5 upon 5. Like you will solve this will not come equal to 2 root 5 upon 5. Now let's check here. This is the radius is given by 2 square. So actually minus 2 square minus 3 square and minus 13. So again, you will check the radius will not come out to be this. So from here you have a x square plus y squared minus 16 by 5x minus 22 by 5y plus 33 is equal to 0. The radius is given by root of 8 by 5 square, 11 by 5 square minus 33 by 5. So this will give me root of 25. So this is 64 plus 1 to 1 minus 33 into 5. This gives me 165 whole divided by 25. Okay. So this will give me like what root of 122 upon 25, or this will be equal to, sorry, 120. So this will be equal to like 5 into, this will be 40. Let me do this from here. So this is equal to root of 20 upon 25, or this will give me, I'm taking 2 outside, so this is root 5 upon 5. So this is my answer. Okay, because its radius came out to be the same, which we calculated in the question. And let's also check for this one: x squared plus y squared minus 3 by 2x minus 3 by 2y minus 11 by 2 is equal to 0. Here the radius will be equal to half the coefficient of this. So this is 3 by 4 square, 3 by 4 square minus plus 11 by 2. You will solve it and you will check that this is not equal to this. So that means we have option C as the answer. Hope you understood. Next is question number 55. If the parabola having its axis parallel to the x-axis passes through these 3 points, then the point at which the parabola cuts the x-axis is. So this question says, the first of all, the equation of the parabola whose axis is parallel to the x-axis is given by y is equal to ax square bx plus c. General equation of parabola whose axis is parallel to x-axis is. You have the 3 points. First is 0, minus 1. In this equation will become minus 1 is equal to 0 plus c, which gives me c is equal to minus 1. Second point, 6 comma 1. So you have 1 is equal to 36a plus 6b. C was equal to minus 1. So this makes 36a plus 6b is equal to 2, or 18a plus 3b is equal to 1. So the third point is minus 2 minus 3. So here is the point minus 2 minus 3. You have minus 3 is equal to 4a minus 2b minus 1. So this makes 4a minus 2b is equal to minus 2, or 2a minus 2b, 2a minus b is equal to minus 1, dividing both sides by 2. So multiply this with the 3, and using this equation as 1, multiplying this equation 3 and subtracting both of them. So you have 18a plus 3b is equal to 1. Then you have 6a minus 3b is equal to minus this. They will cancel. 24a is equal to minus 2. That gives me a is equal to minus 1 by 12. And let's solve for b. So you had here 6a minus 3b is equal to minus 3. So you have minus 1 by 2. I'm filling this a over here. Minus 1 by 2 minus 3b is equal to minus 3. Or you have 3 minus 1 by 2 is equal to 3b. That gives me 5 by 2 is equal to 3b, or b is equal to 5 by 6. So I got the value for a, b, c. Let's write down. A was equal to this, B was equal to 5 by 6, C was equal to -1. Now let's frame the equation again. Y is equal to ax squared, bx plus c. This was the general equation. So y is equal to -1 by 12 x squared plus 5 by 6 x minus 1. Multiplying both sides by 12, you have 12y is equal to minus x squared plus 10y minus 1. So let's frame it properly. You have x squared minus 10x plus 12y plus 1 is equal to 0. Now you have to find out the x coordinate, the point where it cuts the x-axis. The point will be given by x-axis. Let's say this is the point, let's just say any point u and 0. Okay, so here this will be u square at the point u comma 0. This will be given by u squared minus 10u plus 1. Sorry, here was 12. Here was supposed to be 12. Okay, plus 12 is equal to 0. So I can't find any integers to satisfy the equation. So applying the quadratic formula, this will be given by u will be equal to minus of minus 10, that is plus 10 plus minus root of b square minus 4ac upon 2. So this is 10 plus minus root of 52 upon 2, which will be equal to 5 plus minus, this will be root 13. Okay, so 5 plus minus root 13 actually is not present in any of the options, because if I take root 13 as 3.6 also, two possible values will be 5 plus minus 3.6. The one possible value will be 1.4, another will be 8.6, but I don't have any option which is satisfying it. So no option is present to satisfy the given equation. Hope you understood. Next, question number 56. Let S be given by this point 0, 1, 0 and S1 be 0, 1 be the foci of the ellipse. This for any point P on the ellipse, if A, x1, y1 and 1, x2, y2 are the endpoints of the major axis of the ellipse, then what is x1 plus x2? So in the question you are given as P plus S, I'll say dash, right? Let's write it S P plus S dash P is equal to 2 for any point on the ellipse. So focal distances are SP and this is 2A. So SP plus S1P is equal to, I can write it as 2A because you are given in the question A is equal to 1. Now the major axis of an ellipse passes through. Question number 56. Let S be given by this point, S dash be given by this point. They are the foci of the ellipse such that SP plus S dash P is equal to 2 for any point on the ellipse. If A and A dash are the endpoints of the major axis of the ellipse, then what is x1 plus x2? So you are given in the question that SP plus S dash P is equal to 2 for any point on the ellipse. For any point on the ellipse. So focal distances SP and S dash P. I can write it as 2A because in the question A is equal to 1. Now the major axis of the ellipse passes through major axis of ellipse passes through its foci A and A dash, right? This will be located on the X and X axis, will be located on X and Y axis. Since the foci are we are given this 1, 0 and 0, 1, then A will be at -1, 0 and A dash will be at 0, -1 because their points are symmetrically placed with respect to origin, as their points are symmetrically placed with respect to origin. Therefore, some of the x coordinates will be x coordinates, that is x1 plus x2. This will be equal to minus 1. So this is the answer to the question. We have option B as the answer. Hope you understood this. Next is question number 57. It says theta is the angle between the asymptotes of the hyperbola this, and cos theta is 5 by 13. Then what is the value for a squared? So, asymptotes of the given hyperbola of the given hyperbola are y is equal to plus minus b upon a into x. Slope of first asymptote is b upon a, which in this case is 2 upon a. Similarly, you have m2 is equal to minus 2 upon a. Now the angle between the asymptotes, is given by tangent theta is equal to m1 minus m2 upon 1 plus m1 into m2. So this is m1 minus m2. This is b upon a minus of minus this whole divided by 1 plus b upon a minus b upon a. This is equal to 2b upon a upon 1 minus b square upon a square. So that makes tangent theta is equal to b is 2. So 2 into 2 upon a upon 1 minus 2 square, 4 upon a square. So this is equal to 4 upon a into a square upon a square minus 4. Right. So that gives me tangent theta is equal to 4a, because this will cancel upon a square minus 4. So now I have to get to what is tangent theta. You are given in the question that cos theta is equal to 5 by 13. This gives me secant theta is equal to 13 by 5. So what would be tangent theta? This will be equal to secant square theta minus 1. So this is 169 upon 25 minus 1 root under the root. So this is 169 minus 25 upon 25. This is 144 upon 25 or 12 upon 5. Okay. So that makes it 12 upon 5 is equal to 4a upon a square minus 4. Cross multiplication, you have a, first of all, let's cross this. So you have 3a square minus 12 is equal to 5a, or 3a square minus 5a minus 12 is equal to 0. 3a square minus 9a plus 4a minus 12. Or the two factors will be this. Two factors, 3a plus 4a minus 3 is equal to 0. That means a can have the two values as minus 4 by 3 or 3. So a square will be correspondingly 16 upon 9 and 9. So these are the values for a square. Let's check with the options 16 by 9 or 9. You have this option B. This is the correct answer. Hope you understood. Let's move to the next question now. So question number 58 says, let PHK be the point of contact of the tangent to this hyperbola, which is parallel to this line. If P lies in the third quadrant, then what is the value of 3h squared minus 2k? We are given the hyperbola as 5x squared minus 7y squared minus 35 is equal to 0. Writing the standard form, you have dividing both sides by 35. You have x squared minus 7. Sorry, x squared upon 7 minus y squared upon 5 is equal to 1. So here you have a squared as 7 and b squared as 4. Now the equation of line is given as root 2x minus y plus lambda is equal to 0, or y is equal to this. Right, this is the slope. So here you have slope m is equal to root 2. Now equation of tangent is given by y is equal to mx plus minus root of a square into n square minus b square. So y is equal to, this is root 2 x plus minus a square is 7, m square is 2 minus b square was 5. Okay, so you have here y is equal to root 2x plus minus 14 minus 5. This gives me root 9. Okay, so here you have a y is equal to root 2x plus minus 3. So that means y minus root 2x may be equal to 3, or y minus root 2x may be equal to minus 3. Correct. So let's get back to question. P lies in the third quadrant. You have to find out 3h square minus 2k. Here P lies in the third quadrant, 3h squared minus 2k. This is what you need to find out. So first of all, you need to find out the point of intersection. This is the point of contact of the tangent and the hyperbola. So the equation of the hyperbola is 5x squared minus 7y squared minus 35 is equal to 0. Let's multiply this with 2, and let's multiply this. First of all, before multiplying, I will solve this. This will be root 2x is equal to y minus 3. Squaring both sides, you have 2x squared is equal to y squared plus 9 minus 6y, or you have 2x squared minus y squared plus 6y minus 9 is equal to 0. And this one becomes the same thing. This one becomes root 2x is equal to y plus 3. So again, squaring both sides, you have x squared is equal to y squared plus 9 plus 6y, or here's 2x squared. So 2x squared minus y squared minus 9 minus 6y is equal to 0. Now for finding out the point of intersection, let's multiply this with 2 and this with 5. Okay, so this equation now becomes 10x square minus 14y square minus 70 is equal to 0. 10x square minus 14y square minus 70 is equal to 0. And this way equation becomes 10x square minus 5y plus 30y minus 45 is equal to 0. And here it is 10xy, 10x squared minus 5y squared minus 30y minus 45 is equal to 0. So minus plus plus plus, they will cancel, and here will be minus 9y squared. Then you have plus 30y and minus 25 is equal to 0. Multiplying both sides by minus 1, you have this is 9y squared minus 30y plus 25 is equal to 0. This is a perfect square for 3y minus 5. So here you have y is equal to 5 by 3. And from here, this equation minus plus minus plus. So again, cancellations. You have minus 9y squared minus 30y minus 25 is equal to 0. Or multiplying both sides by minus 1, 9y squared 30y plus 25 is equal to 0, or you have 3y plus 5 whole square is equal to 0, y is equal to minus 5 by 3. See, now it is given that P lies in the third quadrant. That means I cannot take this value, because this in this one P lies at this quadrant. Sorry, this coordinate y is equal to 5 by 3 lies in the first or the second quadrant. So I cannot take this. I will take this one only. Okay. Now the corresponding value of x to find out, this was equal to minus 3 from this equation. Okay. So minus 5 upon 3 minus 3 is equal to root 2x, or you have minus 5 minus 9 upon 3 root 2 is equal to x, which is equal to minus 5 upon 3 root 2. Okay, so the coordinate point of contact of tangent to the hyperbola is this. minus 14 upon 3 root 2 minus 5 by 3. Okay. What you had to find out was this 3h squared minus 2k, and this is hk. So this is your h and k. To find was 3h square minus 2k, or 3 minus 14 upon 3 root 2 square minus 2 into this, or this is equal to 3 into 196 upon 9 into 2 plus this. So this will cancel. This will 98. Here you have, so you have 36 as your answer. Okay, that makes option B to be the correct answer. Hope you understood. Next is 59th question. Let fx is equal to modulus of x minus 3 plus modulus of x plus 5, and A be the set which determines A belonging to R, where the limit x approaches A, fx minus fa upon fx minus A exists. Then the number of real numbers which are in this particular range but not in A is given by. So see, you are given that A is limit x approaching A, fx minus fa upon this. So if you fill in the value of this fa like this becomes fx is this minus fa, x minus a. This actually becomes something like this. This. Question number 59. If fx is equal to modulus of x plus 3 plus modulus of x plus 5, and a be determined by this particular relation set of elements, then the number of real numbers which are in this particular range but not in A is. Fine. So you are given here that A is equal to limit x approaching A, fx minus f of A upon x minus A. So if I fill in this becomes A when x approaching A. So this is A minus 3 mod plus A plus 5 mod minus A minus 3 minus A plus 5 divided by A minus A. So they will cancel. This is 0 upon 0 form. So we will apply the L hospital rule. Applying L hospitals rule. A becomes limit x approaching A f dash x upon x minus A derivative. It's 1. Now, fx is equal to x minus 3, x plus 5. From the graph, you have, this is the graph. So this is your coordinate x's. Here is your 3. Here is your minus 5, not minus 3. 8. So here is your 3. Here is your minus 5. So x plus 5 will be something like this. Okay, and x plus 3 will be something like this. X minus 3, sorry. Okay, now because the number of real numbers which are in number of real numbers which are in minus infinity, minus 3, union 5, comma infinity, but not in A, means this does not exist. Therefore, it's clear that the graph at, therefore, it's clear that the graph from the graph that at x is equal to minus 5, sharp corner is present. Therefore, sharp corner is present. Therefore, this does not exist. Hence, left hand limit is not equal to right hand limit at x is equal to -5. Therefore, number of real numbers which are in the given range but not in A is 1. So here you have option C as the answer. Hope you understood. Next is question number 60. So here you have limit x approaching 1, limit y approaching infinity, y into this -1 is equal to. Let's write it down. I'll start solving from here itself. I'll put y is equal to 1 by t. So this now becomes a limit x approaching 1, limit y approaching 0. Sorry, I'm turned y into 1 by t. So this can be when y is approaching infinity, t will tend to 0. So limit t approaches 0, 1 by t e x raised to power t minus 1. Okay, now this is 0 upon 0 form, right? So I'll do what? I'll be applying the L'Hospital's rule. So this becomes limit x approaching 0, limit t approaching 0, and this is 1 upon, actually this is 1 upon t. I'll write it once again. 1 upon t into 1 upon e x, wait. Okay, so limit t approaching 0. This is t itself, right? So this is divided by 1. Question number 60, limit x approaching 1, brackets limit y approaching infinity, y into ex raised to power 1 minus 1 by y minus 1 is equal to. So I'll start solving from here itself. I'll put y is equal to 1 by t. So this will become now question number 60, limit x approaching 1, limit y approaching 0, y into ex raised to power 1 by y minus 1 is equal to. Okay, I'll start solving the sum by putting y is equal to 1 by t. So what does this expression now becomes? Limit x approaching 0, sorry, x approaching 1. See, when y is approaching infinity, t will approach 0. So limit t approaching 0, 1 by t into e raised to power x whole raised to power t minus 1. So this will become now, see, this is of 0 upon 0 form. So I have to apply the hospital's rule over here. Applying L'Hospital rule. Limit x approaching 1, limit t approaching 0. This will be ex power t multiply natural log of ex divided by the derivative of t is 1. So this is the one. Okay. So here this is limit x approaching this ex raised to power 0 natural log ex upon 1. This is nothing but natural log of e, because when x is approaching 1, so that's it. And you know natural log of e is equal to 1 itself. So that means you have option C as your answer. Next is question number 61. Fx is given by this function when x is not equal to 1, and it's given by this function when x is equal to -1. This is right continuous at x is equal to 1. Then what is the value for lambda? So you are having, this is given that it's right continuous at x is equal to -1. So right hand limit at x is equal to -1 is given by f of -1. So limit x approaching -1, this will be root of pi minus root of cos inverse x whole thing divided by root of x plus 1. Yeah, okay. Now what I'll do is I'll put cos inverse x is equal to t, which gives me x is equal to cos t. Or when x is approaching -1, t will approach pi. So this limit now becomes limit t approaching pi, root of pi minus root of t, whole thing divided by 1 plus cos t. So this is limit t approaching pi. This, what I'm doing is just continue. This is 1 minus cos square t whole multiplied by this. Question number 61. If fx is given by this function when x is not equal to -1, and it's given by this function when x is equal to -1, this is right continuous at x is equal to -1, then the value of lambda is. So you are given that the function is right continuous at x is equal to -1. So that means right hand limit at x is equal to -1 is equal to f of -1. That makes limit x approaching 1 -1. This will be pi minus root of cos inverse x whole divided by root of x plus 1. Right? Now I will put cos inverse x as t. That gives me x is equal to cos t. And one more thing, then when x is approaching -1, t will approach infinity. Oh, sorry, pi. So this now limit will become limit t approaching pi, root of pi minus root of t divided by root of 1 plus cos t. What will I do? I'll multiply the numerator and denominator by this. Also by this. Okay. So when I join, this is like a minus b into a plus b. This will be limit t approaching pi. So this is pi minus t upon a plus b into a minus b. This will be 1 minus cos square t. So this will be 1 minus cos t whole divided by root of pi plus root of t. Hope you are clear till here. Okay. Now this becomes limit t approaching pi, pi minus t. Yeah, see, when t is approaching pi, this will be equal to 1 plus 1. This 1 minus cos t. This will be like 1 minus of -1, which will be 1 plus 1. Okay. Then root of here, this is equal to sine square t whole under the root. This will be sine t multiplied by pi plus root pi. Okay. So this is equal to limit t approaching pi. I have already written this, so no need. I have already filled in the limit. So this will be pi minus pi, pi minus t. I'm keeping it as such. T approaching pi upon sine. I can write it like this, sine pi minus t into root 2 upon 2 root pi. So this, see, limit t approaching pi, pi minus t upon sine pi minus t, this and this will cancel. So you have this. So this multiplied by this thing. So, this is equal to 1. So you have 1 upon root 2 pi, right? This is because sine x upon x is equal to 1. So left hand limit is equal to right hand limit is equal to f of -1. That makes 1 upon root 2 pi is equal to, it was 1 upon okay, this was whole under the root and this. So this is equal to 1 upon lambda pi. Okay, that gives you lambda is equal to 2. So here you have the value lambda is equal to 2. Option D is the correct answer. Hope you understood. Next question number 62. If y is equal to x into log of this, then what is x into x plus 1? Second derivative of y with respect to x plus x into dy by dx minus y. So here you are given y is equal to x log 1 upon ax plus 1 upon a. On differentiating both sides with respect to x, you have dy by dx is equal to first function derivative of second. So this is log first function derivative of second. So here you have log. First of all, let's write it properly. This can be written as 1 plus x upon ax. Now it's easy to go. So this is first function to derivative of second. Like I'm writing out this as the first function. So this into derivative of x. Then here this will be minus x into this is ax upon 1 plus x multiplied by like ax square, denominator square into ax multiplied by 1 minus 1 plus x into a. So this is equal to log 1 plus x upon ax minus ax square upon 1 plus x multiplied by ax minus a minus ax whole divided by a square x square. So x square, this will cancel and this will cancel. This will be log 1 plus x upon ax, and these two terms will also cancel. Minus minus, it will be plus. Then here you have this a upon a into 1 plus x. This a and a will cancel. There's a small change. Sorry, there was supposed to be plus because first function derivative of second plus second function derivative of first. So this was plus and this will be now minus. So this is equal to log 1 plus x upon ax minus 1 upon 1 plus x. Okay, let's write it clearly once again. Dy by dx is equal to log 1 plus x upon ax minus 1 upon 1 plus x. Okay, and what is your y? Y was equal to this. So dy by dx, I can write it like this, y upon x minus this. Yes. Now let's differentiate again with respect to x. So we have d square y upon dx squared is equal to, here I'm squaring the denominator. So first function denominator into the derivative of the numerator minus numerator into the derivative of denominator. Okay. Plus because mine this will be 1 plus x whole square. So minus minus it will be plus now. That's it. 1. Okay. So this is equal to d square y upon dx square will be equal to, you have to write down dy by dx again now, which was x into y by x minus 1 upon 1 plus x minus y upon whole thing divided by x squared plus 1 upon this. Okay. So this will be y minus x upon 1 plus x minus y. Again, they will cancel. This is upon x square plus 1 upon 1 plus x whole square. So this will be minus x upon 1 plus x into x square. So this again will cancel, plus 1 plus x whole square. Let's take the LCM, 1 plus x whole square. This will be x into 1 plus x whole square. This will be minus 1 plus x minus x plus x. Okay. So this will be minus 1 upon x into 1 plus x whole square. This is your second derivative of y with respect to x. Now, what you had to find out in the question was this. Let's go for this. So filling everything in this equation 1. So using equation 1, you have what was there in the equation? It was x into 1 plus x d square y upon dx square plus x into dy by dx plus minus y is equal to. Okay, so now just let's fill in the values. First of all, you already have a d square y that was equal to minus 1 upon x into 1 plus x whole square. X, and this will cancel, plus x into minus y upon this minus y. Right? What was y equal to? Okay, fill that later. So this becomes a minus 1 upon 1 plus x. X and x will cancel, minus 1 upon 1 plus x whole square minus y. Right? What I'll do is this was equal to y minus x only, right? I'll fill in this way. So I'm going to use y upon x over here. Okay, x and x will cancel, and there will be y only plus, right? So they will again cancel. So this is equal to question number 62. Y is equal to this function, then x into x plus 1 d square y plus x into dy by dx minus y is equal to. So you're given y is equal to x into log of 1 upon ax plus 1 upon a, which can be written as x into log of 1 plus x upon ax. So this is the two functions. Let's differentiate both sides with respect to it. So dx upon dy is equal to first function into derivative of second. So first function into derivative of second, which is equal to ax upon this into derivative of this now. So this is ax square into ax into 1 minus 1 plus x into a plus second function into derivative of first. So here you have like this is x square and this, okay, I'll write it properly. So this is ax square upon 1 plus x square multiplied by ax minus a plus ax upon a square x square. X square will cancel, 1a will cancel, and this cancels. Here is plus log 1 plus x upon ax. Okay, right. So this is equal to minus a upon 1 plus uh, x. No, this is square. No square is there. So 1 plus x into a. Again, the a and a will cancel. Plus, see, you had already in the question you are given y is equal to log of this, right? So log of 1 plus x upon ax is equal to y upon x. Correct? So I can write it like y upon x. This gives me dy by dx is equal to y upon x minus 1 upon 1 plus x. Now again, differentiating it with respect to x, you have a denominator square, first denominator into dy by dx minus numerator into derivative of denominator, minus this will be 1 plus x whole square minus it will be plus. Okay, so you already know that dy by dx is equal to this. I'm going to fill over here. This is y upon x minus this thing minus y upon x square plus 1 upon 1 plus x square. So you have y minus first of all, wait, yeah, y minus x upon 1 plus x minus y upon x square plus this thing. They will cancel again. So you have On solving like this, x and 1x will also cancel. You have 1 minus 1 upon x into 1 plus x plus 1 upon 1 plus x whole square. So this is 1 plus x whole square, x also being multiplied. So minus 1 plus x minus x, right? Okay, this gives me minus 1 upon x into 1 plus x whole square. So this is my second derivative of y with respect to x. Now let's get back to our equation. To find was x into x plus 1 d square y upon dx square plus x into dy by dx minus y is equal to what? So x into x plus 1, this was equal to minus 1 upon x, 1 plus x whole square plus x dy by dx. This is y minus x minus 1, 1 upon 1 plus x minus y. Okay, so this is being multiplied. This will cancel, this one and this one will cancel. So minus 1 upon 1 plus x plus y minus x upon 1 plus x minus y. Y and y again cancels. LCM 1 plus x minus y, minus 1 minus x. I'm taking this common. So you have minus 1 as your answer. So here you have option C as the correct answer. Hope you understood this. Let's move to the next question. Question number 6. If fx is equal to this function when x is not equal to 0 and it's equal to 0 when x is equal to 0, then what is the value for limit x approaching 0, fx minus f0 upon x? So I'll start from here also only the limit x approaching 0, fx minus f0 upon x. This can be written as limit x approaching 0, fx, and you know f of 0 is equal to 0, it's already given, minus 0 upon limit x approaching 0, x, right? So limit x approaching 0, fx is equal to limit x approaching 0, x into 1 plus 1 by 2 sine of log x square according to the question and this function. So limit x approaching 0, x into 1 plus 1 by 2 sine log x square. I'll do one thing, I'll multiply the numerator and denominator by log x square, right? So this is equal to limit x approaching 0, x into 1 plus 1 by 2. See, this will be 1. When I'll be opening the limits, this will be equal to 1. So this is multiplied by 1 into log x square, right? Because log of, because x square, because sine of x upon x is equal to 1. Okay. So here you have a limit x approaching 0. This can be written as x into 1 plus 1 by 2 into 2 log x, or this will be 1 plus log x, right? This is I have used over here log x raised to power m is equal to m into log x. Okay. So when x is approaching 0, so see, log of 0, this does not exist. So x into 1 plus log x, when x is approaching 0, this does not exist. Okay, so therefore limit x approaching 0, fx minus 0 upon x, this also does not exist. Hence, LHL and RHL of the function at x is equal to 0 does not exist. And therefore, limit this fx f0 upon x does not exist. That makes option B to be the answer. Hope you understood. Next is 64th question. If fx is equal to max of cos x, sin x, and 0, if the number of points at which fx is not differentiable in this range is 1012k, then what is the value for k? See, you're having the function as max of the three, cos, sine, and 0. Okay, so if I see this function on the graph, so this will look something like this. This is for sine. All right, and this is for cos. Something like, okay, not exactly, but something like this. Okay, so this is for pi by 2. This is the sine. Sorry, this is for cos, and this is for sine. This is not actually up to the scale, but this is for pi by 2, pi, and here is 3 pi by 2, and so on. Now, in the range 0 to 2 pi, the number of points at which fx is not differentiable is how many? See from here, it's 3. Okay, therefore, for 0 to 2024 pi, total number of points at which the function is not differentiable is 3 into 2 into, wait, 2024 divided by 2, which is 3 into 1012. So this is it. This is equal to 1012 into k. So that means the k over here is 3. That means we have option C as the correct answer. Hope you understood. Next question, number 65. If fx is given by this function, attains a local minimum and local maximum values at x is equal to -2 and x is equal to 2 respectively, and p is a root of this equation, then what is the value of p plus q plus r? So you're given fx is equal to px cube, qx square. Here is supposed to be r, rx plus t. Let's differentiate. So you have 3px squared 2qx plus r. Let's say this is equation 1. Now for maximum or minimum values, the first derivative should be 0. For max or min values of fx, this derivative should be equal to 0. Also, the maximum and minimum values of fx at x is equal to 2 and -2. This is given by x minus 2 into x plus 2 is equal to 0, or x squared minus 4 is equal to 0. Let's say this is equation 2. Okay. Now, on comparing both the equations, see the equation 1 was a 3px square plus 2qx plus r is equal to 0. This was from equation 1. So if I compare, you have a 3p is equal to 1, 2q is equal to 0, and r is equal to -4. This gives me p is equal to 1 by 3, q 0, and r is equal to -4. Also, you are given that p is the root of this equation. So p is a root of 9x squared minus 1 is equal to 0, which is 3x squared minus 1 is equal to 0, or 3x plus 1, 3x minus 1 is equal to 0, or x can be equal to 1 by 3 or -1 by 3. So, okay, now p is one of the roots, so that means I got p as 1 by 3. I'll choose this one. Now you had to find out what was p plus q plus r. So this is 1 by 3 plus 0 minus 4. This will give me -11 upon 3. So this is the answer, but this is not present in any of the options, but this is the answer to our question. Hope you understood this. Let's move to the next question. Question number 60. The tangent drawn at A2, 1 to this curve meets the curve at the point B. Then which of the following is true? I'll pick up the expression first. You are having x is equal to 1 plus 1 upon y squared, differentiating both sides with respect to x. 1 is equal to 0 minus y cube. And here you will have 2 into dy by dx. So writing it clearly, dy by dx is equal to minus y cube upon 2. Now let's put this point a2, 1. Now at 2, 1, we get, this is equal to the slope. So m is equal to dy by dx is equal to minus 1 by 2. We know that the equation of the tangent is given by tangent is given by y minus y1 is equal to m into x minus x1. So y minus 1 is equal to minus 1 upon 2 x minus 2, or you have 2y minus 2 is equal to this, or you have x plus 2y is equal to 4, or this thing. Let's say this is equation 2 and this is equation 1 and this is equation 3. Now put x is equal to 4 minus 2y in equation 1. We get 4 minus 2y is equal to 1 plus y, 1 upon y square. So 4 minus 2y is equal to y square plus 1 upon y square, or 4y square minus 2y cube is equal to y square plus 1. 2y cube minus 3y square plus 1 is equal to 0. So y minus 1 is a factor of this equation. 2y cube minus 3y square plus 1. So you will have, and you will divide it with the y minus 2, on like dividing 2y cube minus 3y square plus 1 with y minus 1. The two factors which you will get is y minus 1 into y minus 1 into 2y plus 1 is equal to 0, which is this, which can be written like this. Here y is equal to minus 1 by 2, or y can be equal to 1, right? So what was this equal to? Y is equal to minus 1 by 2. X is equal to, this gives me 4 plus 1. This is from equation 3, right? That means x is equal to 5. So what will be y? Y will be equal to 5 minus 1 by 2 for any point B. Now angle between the tangents drawn at A and B, is y2 minus y1 upon x2 minus x1. This is minus 1 by 2 minus this 5 minus 2, which is equal to 1 by 2. So that means tangent, this is equal to tangent theta. Tangent theta is equal to 1 by 2. So angle between the tangents drawn at A and B is neither 0 nor pi by 2. Angles between tangents drawn at A and B is neither 0 nor pi by 2. So let's see, you have option B as the answer. Hope you got that. Next is 67th question. The points on this curve are which the normal is parallel to the y-axis lie on. Which of the following options is true for that? So you are having y square is equal to x plus sine x. For determining the slope, you differentiate both sides with respect to x. So 2y dy by dx is equal to 1 plus cos x, or dy by dx is equal to 1 plus cos x upon 2y. So this is the slope of that curve. So slope of the normal will be given by minus 1 upon dy by dx, which is equal to minus, this will be minus 2y upon 1 plus cos x. Now, for being parallel to y-axis, parallel to y-axis, slope of the normal, because it's 90 degree, so it should be infinity. That means 1 plus cos x should be 0, or cos x should be equal to minus 1. That gives you x is equal to, okay, I'm squaring both sides. Cos square is equal to 1, so 1 minus sine square x is equal to 1. That gives you sine square x is equal to 0, or sine x is equal to 0. So let's say this is equation 2, right? And now from equation 1, which we startedly assumed, like let's say this is equation 1, I'm going to fill in equation 1 or these things. From equation 1, you have y squared is equal to x, because sin x came out to be 0 from equation 2. Therefore, points on the curve y squared is equal to this, at which normal is parallel to y-axis, lies on the parabola. That makes option, let's check, you have option C as the correct answer. Right. Hope you understood this. Next is question number 68. Given that the solid obtained by rotating a rectangle about one of its sides is a cylinder, if the perimeter of the rectangle is 48 centimeter, volume of the cylinder formed by rotating it is maximum, then the dimensions of that rectangle is. Okay, first of all, let's say the dimensions length and breadth are x and y. Let's see dimensions. Let the dimensions of rectangle are x and y. So we are given that the perimeter is this. So 2x plus y is 48, or this is equal to 24, or you can say y is equal to 24 minus x. Now we know volume of the cylinder is pi r square h. Here in this case, r is x and h is y. So this is pi x square y. Now let's put the value of y in this equation. So volume will be given by pi x square 24 minus x. This is equal to 24 pi x square minus pi x cube. Let's differentiate both sides with respect to x. So you have dv by dx is equal to 48 pi x minus 3 pi x square. If you have dv, like for the maximum volume, you have the first derivative as 0. For maximum volume, the first derivative should be equal to 0. So dv by dx is equal to 0. That means 48 pi x minus 3 pi x square should be equal to 0. Or I'm taking 3 pi x common, and 16 minus x is equal to 0. This gives me x is equal to 0, or x is equal to 16. Right, x cannot be equal to 0, so I'm taking x is equal to 16 as the value. So dv upon dx, this was equal to 48 pi x minus 3 pi x square. Now differentiating again with respect to x, d square v upon dx square, this is equal to 48 pi minus 6 pi x. Right. And if I fill in the value for x at x is equal to 16, this 48 pi minus 6 into 16 into pi. So this is 48 minus 96 pi, which is minus 48 pi, which is less than 0. So the second derivative comes out to be negative. Therefore, volume is max at x is equal to 16. And for x is equal to 16, the corresponding value of y will be equal to, y was equal to 24 minus x. So that's 8. So dimensions are 16 and 8 units for the rectangle. Okay, now let's check with the options. You have option, this is x came out to be 16 and y came out to be 8, like they are written alternatively. It's no, doesn't matter. So you have option D as the answer. Hope you understood. Next is question number 69. So now integral problem before us. Let's go for this. So you're having x square minus 1 upon this thing. I'll do one thing. I'm dividing the numerator and the denominator by x raised to power 5. What you will get over here is x square minus 1 upon x power 5 whole thing divided by x cube to x4 to x square plus 1, right? Yeah, dx. So this becomes integral of 1 upon x cube minus 1 upon x power 5 whole thing divided by like this will cancel with 2 here and I'm taking it inside, so this will be root of 2x raised to power 4 minus 2x square plus 1 whole thing divided by x raised to power 4 dx. So that makes it 1 minus x cube upon this whole thing divided by this will be root of 2 minus 2 upon x square 1 upon x raised to power 4 dx. Now I'm going to put this thing as t. So differentiating, you have 4x cube minus 4x power 5 dx is equal to dt, or I'm taking the 4 common. 1 upon x cube minus 1 upon x raised to power 5 dx is equal to 1 by 4 dt. Hope you are clear till here. Now, further substituting these in the above this equation, okay, in equation 1. Substituting these in equation 1, you will get the integral of dt upon 4 root t, which is equal to 1 by 4 I have taken outside, t raised to power minus 1 by 2 into dt. So 1 by 4 t raised to power minus 1 by 2 plus 1 upon minus 1 by 2 plus 1 plus the constant c minus 1 by 4. Here is t power 1 by 2, 1 by 2 plus c. This is equal to this. Now let's fill in the value for t. So this becomes equal to root of 2 minus 2 upon x squared plus 1 upon x power 4 whole thing divided by 2 plus c. And writing it properly, you have a 2x square minus 2x 2x4 minus 2x square plus 1 whole under the root divided by 2x square plus c. So let's check with the options where you have the correct answer. Option B. Hope you understood this. Next is question number 70. Fx is equal to x square when x lies between 0 and 1, and it's equal to root of x when x lies between 1 and 2. Then integral z limit 0 to 2 fx dx is equal to. Okay, you have to find out this, right? 0 to 2 fx dx. This I can split it up like this. 0 to 1. Like from 0 to 1, it is x square dx, and from 1 to 2, it is root x dx. Easy to differentiate. So x cubed by 3, limit 0 to 1, plus x raised to power 3 by 2 divided by 3 by 2, limits 1 to 2. You will have here 1 minus 0, 1 upon 3 actually, minus 0, plus this will be 2 by 3, and here is 2 raised to power 3 by 2 minus 1 raised to power 3 by 2. So this is equal to 1 plus 3 plus 1 upon 3 by this, and this is 8 root, which is 8 root is given by 2 root 2 minus 1. Okay, so that makes it 1 by 3 plus 4 by 3 root 2 minus 2 by 3, or this will be equal to 4 root 2 minus 1 upon 3. So this is the answer to the question, and we have option A as the answer. Hope you understood. Next is question number 71. If the graph of antiderivative of gx of fx is given by this, passes through this point, then the term independent of x in gx is k. The sum of all digits of k is. Okay, so let's understand the problem very clearly before starting. So it says that if the graph of the antiderivative of gx of fx, which is given by this, passes through this point, and the term independent of x in gx is given by k, you have to find out the sum of all digits of k. Basically, you have to find out k. Now, an antiderivative of the function, let's say antiderivative of the function is given by fx. Now, this is given by integral of antiderivative, right? Log of x plus log of x raised to power minus 2 dx plus constant. Now, using integration by part in the first term, you will get it as x into log of log x minus x into log x inverse plus integral of log x raised to power minus 2 dx plus integral of log x raised to power minus 2 dx plus k. Yeah, okay. So that becomes x into log of log x, right? Because these two terms, when you will open this minus and minus, these two terms will cancel. Minus x into log x inverse plus k. Now let's put x is equal to e, which is from here. Put x is equal to e. What we have is 2023 minus e is equal to e into 0 minus e plus k. Will be write it properly. 2023 minus e is equal to minus e plus k. That gives you k is equal to 2023. Now sum of digits of k, 2 plus this, that is 7. So this is the answer to the question. Option C is the correct answer. Next is question number 72. Students, before starting with the question, is a quick reminder to visit our website www.examsnet.com. There you can practice this one and similar type of multiple entrance exam question papers. You must download our app for a better preparation. The link is available in the description box. So let's start with question number 72. So you have to find out the integral of 3 raised to power minus log to the base 9 x square dx. Let's say this is equal to I. So I is equal to integral of 3 raised to power minus log. Now 9 can be written as 3 square. The base I'm changing. Raised to, here is x square dx, right? So therefore, see, log to the base b, a into k is equal to, Question number 72. Students, before starting with the questions, a quick reminder to visit our website www.examsnet.com. Here you can find out this question paper with its detailed PDF solution and many more similar entrance exam question papers. For a better preparation, you must download our app. The link is available in the description box. So here we go. Question number 72. It says you have to find out the integral of 3 raised to power this. So I can let's say this is equal to I. So now I can be written as 3 raised to power minus log 9 can be written as 3 square x square dx, which is equal to integral of minus 1 by 2 log 3 x square. Right. So now this is equal to 3 raised to power log to the base 3 x square into minus 1 by 2 dx. So this will be equal to integral of 3 log to the base 3 x to the power minus 1, right, dx. So integral this is equal to, this will be 3 raised to, sorry, this was 3 raised to power, right? So 3 raised to power this, 3 raised to power log to the base 3, x raised to power minus 1 is nothing but x raised to power minus 1 dx. So this is equal to 1 upon x dx. So integral will be equal to log of mod of x plus c. That needs option B to be the answer. Hope you understood. Next is question number 73. Integral limit 0 to 1 by 2 x into sine inverse x upon this dx is equal to what? So you are having, let's say this is equal to I. In this question, let's put sine inverse x is equal to some k. So differentiating both sides with respect to x, 1 upon root of minus 1 minus, sorry, differentiating both sides with respect to x, 1 upon root of 1 minus x square dx is equal to dk, right? So now I'm going to put this thing in the integral. This will be I is equal to, now the limits will change. When x is approaching 0, k will be equal to 0. And when x is approaching 1 by 2, k will approach to pi by 6. So this is, the limits will change 0 to pi by 6 sine k into k dk. Because from here you have x is equal to sine k. Okay. Now I is equal to k0 to pi by 6 sine k into dk minus integral of 0 to pi by 6 dk upon dk whole thing integral of 0 to pi by 6 sine k dk dk. So you have I is equal to, this will be minus k cos k. Limits will be, yeah, the limits will be from 0 to pi by 6 minus integral of limit 0 to pi by 6 minus cos k dk. So the integral I is equal to minus k cos k plus sine k, limits this, or this is equal to minus pi by 6 into root 3 by 2. So this gives me I is equal to 1 by 2 minus 3 pi upon 12, right? So yeah, root 3 pi by 12. So this is the answer to the question. And let's check with the options. You have option B as the correct answer. Hope you understood this. Let's move to the next question. Question number 74. Given that d by dx of this integral function where phi derivative fx into f dash x is equal. Question number 74. Given that this derivative is equal to this function, if 0 to x cube, here is x cube into ft dt is equal to x square sine pi 2 pi x, then the value of f8 is. I'll start with the you're given this thing, right? And but I'll start with, if this is equal to this, I'm going to start from here. So limit 0 to, sorry, not limit, integral 0 to x cube ft dt. This is equal to x square sine 2 pi x. So here you have if I'm putting the limits, this will be fx cube into 3x square is equal to, I'm differentiating both sides. So this will be 2x into sine 2 pi x plus x square cos 2 pi x into 2 pi. When x is equal to 2, you will have f of 8, right? Here will be f of 8 is equal, f of 8 into 3 into 2 square is equal to 2 into 2 sine 4 pi 2 square cos 4 pi into 2 pi. That makes it 12. F8 is equal to 0 plus 8 pi cos 4 pi. So, you know, cos 4 pi, this is 1. So you have 12 F8 is equal to 8 pi, or F8 is equal to 8 pi upon 12, or this is equal to 2 pi upon 3. So here you have option A as the answer, right? So let's move to the next question now. Question number 75. Limit n approaching infinity 1 upon n, 1 plus e raised to power 1 by n plus 1 upon e raised to power 2 by n, so on till e 1 upon e raised to power 2 is equal to. So you have this thing, limit n approaching infinity, 1 by n, 1 upon e raised to power 1 by n, 1 upon e raised to power 2 by n, 3 by n, e square. So this is equal to limit n approaching infinity submission, sorry, not limit, I'm just used to saying that. Wait, I'm not writing. Yeah. So limit n approaching infinity submission r is equal to 1 till 2n, 1 into 1 upon n into e raised to power r upon n, right? Now put r upon n is equal to x. So differentiating both sides with respect to x, you will have 1 by n is equal to dx. Lower limit r is equal to 1, then x is equal to 0, and when r is upper limit, when r is equal to 2n, then x is equal to 2. So you have this integral as 0 to 2, 1 upon e power x dx. So this will be minus e raised to power minus x, limits this. Or you have e raised to power minus 2. I'm taking the minus outside. Minus 1, or this is 1 minus e raised to power minus 2. This is the answer, and you have option A as the correct answer. All right. Next is question number 76. If integral 0 to 2024 pi, this whole expression dx is equal to k, then what is the value for this expression? So here you have I is equal to 0 to 2024 pi, 2023 sine square raised to power sine square x, sine square x divided by 2023 sine square x plus 2023 cos square x dx. This is equal to k, right? Now I'm going to use the property using integral limit 0 to a fx dx is equal to 2 fx dx 0 to a. So I'm going to use this in this particular integral. This will be equal to I is equal to 2024 into 2, 0 to pi by 2, 2023 sine raised to power sine square x divided by 2023 sine square x plus 2023 cos square x dx. Hope this is clear till here. Now further, this can be written as a 4048, limit 0 from 0 to pi by 2. Same thing, sine square x whole divided by 2023 sine square x 2023 cos square x dx. Again, using the same one more property, that is 0 to a limit fx dx can be written as 0 to a f of a minus x dx. So this I now will be 4048 0 to pi by 2 2023 sine square pi minus x 2023 sine square pi by 2 minus x 2023 cos square pi by 2 minus x dx. So this I now becomes 4048 integral 0 to pi by 2. This will be converted to cos square x upon 2023 raised to power cos square x 2023 raised to power sine square x dx. Let's say this is number 2 and let's say this is equation 1. Now adding 1 and 2. Wait. Yeah. Adding 1 and 2. You have 2I is equal to 4048 integral of 2023 raised to power sine square x 2023 raised to power cos square x whole thing divided by 2023 sine square x 2023 cos square x into dx. So they will cancel. You have 2I is equal to 4048 integral of this was this 0 to pi by 2 1 dx. So you have a 2. I'm taking this now. I taking this 2 over here. So this is 2024 x 0 to pi by 2, or you have a 2024 pi by 2, right? That was equal to your integral I. Okay, that's 1012 pi. Okay, now you are given that this is equal to k, then you have to find out this value. So this is equal to k. Now to find was 2k upon pi plus 1. So this is equal to 2 into 1012 pi upon pi plus 1. This will cancel 2024 plus 1. This is 2025. This is the answer to the question 2025. We have option B as the correct answer. Hope you understood. Next is 77th question. The area bounded by the curves this, y, this, and the x-axis. I'm repeating, the area bounded by this curve, and the x-axis between x is equal to 0 and x is equal to pi is given by. Okay, let's make the curves first. So here is your axis. Okay, uh, this is given by, for the sin x, the curve will look something like this. So for this is pi by 2. This curve is y is equal to sin x, and of course this is your x-axis, and the another one y is equal to 1 plus cos x. This one will be given by like this is minus pi, and this is pi. So it will be given by, I have to make it wait, something like this. From here, it will go down. And again at 2 pi, it will come like this. Okay. This is the curve. Y is equal to 1 plus cos x. And of course, you know the x-axis. So the required area between x is equal to 0 and x is equal to pi. Required area is given by from 0 to pi by 2, you have to consider sine x dx. From pi by 2 to pi, you have to consider 1 plus cos x dx. So this is equal to minus cos x, limits same, plus 1 x plus sine x, limit pi by 2 to pi. Okay, so this is of course 0, and cos pi by 2, this is 0, minus of minus 1, and plus you have here pi plus 0 minus pi by 2 minus 1. So you have 1 plus pi by 2 minus 1, that is equal to pi by 2. So here you have pi by 2 as the correct answer. That makes option D to be the correct answer to the question. Hope you understood this. Next is question number 78. If limit to x approaching 0, yx is equal to pi by 2, then the solution for x cube into sine y into dy by dx is equal to 2 is cos y is equal to. So here you have limit x approaching infinity, yx is equal to pi by 2. Now you are also given x cube sine y dy by dx is equal to 2, or you have sine y dy is equal to 2 into 2 upon x cube into dx. Now integrating both sides. Integrating both sides, what you get is integral of sine y dy is equal to 2 upon x cube into dx. This will be minus cos y is equal to minus 2 upon x raised to power 3 minus 2. So this is this. Okay, plus c. So you have a cos y is equal to minus this plus c, or you have cos y is equal to 1 upon x squared plus c, right? Now, limit when x was approaching infinity, yx is equal to pi by 2. This gives you c is equal to 0. So now this cos y becomes equal to 1 upon x square only. So this is the answer. Option C is the correct answer. Hope you understood this. Next is question number 79. A, B, C, D are arbitrary constants. Then the corresponding differential equation to this particular equation is what? Okay, let's write down. You are having y is equal to a into e raised to power x, b e raised to power minus x, c cos x, d sin x. So let's find out the first derivative of y. This will be this minus this minus this plus this. Second derivative, this sorry, minus c cos x, and the third derivative aex minus be minus x plus c sin x minus d cos x, and the fourth derivative aex plus be minus x c cos x d sin x. So you see one thing, you got fourth derivative again equal to y, right? That means option A is the correct answer. Hope you understood. Next is question number 80. This is going to be the last question for the paper. A very best of luck. Hope you understood the whole series very well. Let's start with this. So here you have, you are given that y is equal to yx is a solution for this particular equation. Y pi by 2 is given by pi squared by 8. Then what is the value for value of y at x is equal to pi? Okay. So you are given many things. Let's write them. First thing, you are given y is equal to yx, and then you have dy by dx is equal to x minus this y cos x upon this. Yeah, I'm going to start from here. So you have dy by dx is equal to this. Let's do the cross multiplication. You have dy by dx 1 plus sine x is equal to x minus y cos of x. That gives you dy by dx 1 plus sine x y cos x is equal to x, or mm, wait. I'll do one thing. I'm going to divide both the sides by 1 plus sine x. This is equal to x. I'll start from here. So dividing both sides by 1 plus sine x, you will have dy by dx plus y into cos x upon this is equal to x upon 1 plus sine x. Now this differential equation is of the form dy by dx plus py is equal to q. Here you have p as cos x upon 1 plus sine x and q as x upon 1 plus sine x. So here in the question, you have integrating factor as e raised to power p dx. So you have e raised to power cos x 1 plus sine x dx. So the integrating factor is given by log e raised to power log 1 plus sine x. This is nothing but 1 plus sine x itself. So since y into integrating factor is equal to q into integrating factor dx, so you have y into 1 plus sine x is equal to integral of x upon 1 plus sine x into this dx. So y into 1 plus sine x is equal to, they will cancel, and the integral of x is x squared by 2 plus c. Now you're given that y of pi by 2 is equal to pi squared upon 8. So pi squared upon 8 into 1 plus sine pi by 2 is equal to pi by 2 square into 1 by 2 plus c. So you will have pi square by 8. 1 plus 1 is equal to pi square by 8 plus c. Or this will be 2, will be like this is 2, and this will be cancelled. So pi square by 4 is equal to pi square by 8 plus c. Or you will have c is equal to pi square by 4 minus pi square by 8. So 8 to pi square minus pi square, or this is equal to pi square by 8. C is equal to pi square by 8. Now this equation, let's say equation 1 becomes y into 1 plus sine x is equal to pi square by 2 plus pi square by 8, or y into 1 plus, sorry, here is pi. Okay, because we have to find out y of pi. Okay, I'll do that later. Let's keep it x only. So this is x sine x. So y into 1 plus sine x is equal to 4 pi square plus pi square, which is 5 pi square upon 8. Now you have to find out y of pi. So this is y into 1 plus Sine pi is 5 pi square by 8. Sine pi is 0. So y into this is this, or y is equal to 5 pi square by 8. So this is the answer to the question, 5 pi square by 8. Let's check with the options. You have option A as the answer. So students, with that, we have completed all the 80 questions of this paper. Hope you understood them well. And the students, don't forget once again to visit our website www.examsnet.com. Here you can see this one and many more entrance exam question papers with the detailed PDF solutions. You must download our app for better preparation. So very best of luck for your exams. Keep shining, keep rising high. That's all for this paper. Bye. And don't forget to visit our physics and chemistry sections as well.